quadratic equations. Now we were doing about common roots, the common roots of a quadratic equation. Can you please turn to page 3, please? Page 3. Now, when we have two quadratic equations, say ax square plus bx plus c equal to 0 and px square plus qx plus r equal to 0. Then we say that these two equations have a common root. That means there is a root which is a root of the first equation as well as the second equation. So we want to at times find conditions on the coefficients that they have a common root, or sometimes we want to find the common root. So what it says is to find the common root of two equations, make the coefficient of x the same. So if we have, say, if I just take that one, whatever, what you can do is if alpha is a common root, this is what you will put. Instead of x, we'll write alpha. And we have to find the value of alpha, say. We are asked to find the common root. What we'll do is we'll eliminate either alpha square or alpha. What you can do, you multiply this by minus q and this by b and add. And so you will eliminate alpha and you will get a relationship between alpha square and the coefficients, and you can find the value of alpha. Right? So we'll take up a question and you will be able to see. I'll just tell you 2-3 points regarding this. If two quadratic equations with real coefficients have a complex common root, what did we say? That if an equation has a complex root, it occurs in pairs. Now, if there is a complex root, say p plus iq, which is common to both the equations have p plus iq as a root, so it will also have p minus iq also, so both roots will be common. That means the coefficients of the equations are identical. That means the coefficients are proportional. This is what point number 2 says. Now, point number 3 says that if you have a quadratic equation, two quadratic equations with rational coefficients, and there is an irrational common root, and as we did yesterday, the irrational root, if there is an irrational root, p plus root q, where q is not a perfect square and q is non-zero, then p minus root q will also be a root. So again, the two equations will become identical and both the roots will be common. That means the coefficients will be proportional. Also, we have a very important result, not just for quadratic equations, but if fx is a polynomial of any degree, then if it has a repeated root alpha, fx has a repeated root alpha, then f dash x will also have, it will also be a root of f dash x. If alpha is a root of fx repeated 2 times, then it will be a root of f dash x repeated once. And it's not just for equations of second degree. It's for equations of polynomial equations of any degree. It's a very important result. Then point number 5, if alpha is a repeated common root of two quadratic equations, can you just slide this? That's it. If alpha is a repeated common root of two quadratic equations, fx equal to 0 and gx equal to 0, then alpha is also a common root of f dash x equal to 0 and g dash x. So let us take up a question. Can you turn to questions on page 9, I think, 8 or 9? Yes. Question number 10. Question number 10. This is about question number 10 says, find k such that the equations x square minus x minus 12 and kx square plus 10x plus 3 equal to 0 have a common root. So let alpha be the common root. Let alpha be the common root. So what will you have? Can I just get the question, please? Alpha square minus alpha minus 12 is 0, and k alpha square plus 10 alpha plus 3 is 0. These are the two equations you get. Treat them as two quadratic equations, two equations in the unknown alpha square and alpha. The unknowns you can take are alpha square and alpha. So what will you have? Alpha square over minus 3 plus 120 is equal to alpha minus alpha over 3 plus 12k is equal to 1 over 10 plus k. Solving these two equations in the unknowns alpha square and alpha, these two equations, this is what you will get. So now find the value of alpha. You can get the value of alpha square from here, value of alpha from this and this. This combined with this will give you alpha square. This combined with this will give you alpha. Equate the value of alpha square. From here you'll get alpha square also. Is that okay? So you can complete it, and what you will get is, when you simplify, you will get 16k square minus 5k minus 129 is 0. So k minus 3 into 16k plus 43 is 0, which gives you k is 3 or minus 43 by 16. These are the values that you get. Is that clear? Now let us just turn to page 2, please. Yes? How do I write this? 10th class ka hai. You solve these equations, a1x plus b1y plus c1 equal to 0, and a2x plus b2y plus c2 equal to 0. क्या लिखते हैं? x over b1 c2 minus b2 c1, है ना? याद आ गया? Is equal to minus y over a1 c2 minus a2 c1 is equal to 1 over a1 b2 minus a2 b1. तो यहाँ एक वेरिएबल हमारा अल्फा स्क्वायर है, दूसरा वेरिएबल अल्फा है. तो वही लिखा है मैंने, अल्फा स्क्वायर ओवर दिस इंटू दिस माइनस 1 इंटू 3 माइनस दिस इंटू दिस, तो प्लस 120 हो जाएगा. ये फॉर्मूला लगाया. तो यहाँ से अल्फा स्क्वायर की वैल्यू आ गई और यहाँ से अल्फा की. So value of alpha square is the value of alpha whole square. That you will simplify. Because if I do all the calculations, I'll be able to do very few problems. We have just limited time. So this is straightforward formula simplification. So that's why I've left it to you. And I've told you what your final result will be. Okay. Now page number 2, please. Page number 2. नहीं, पेज नंबर, हाँ, इस नेक्स्ट वन, इसके नीचे 3. या फॉर्मेशन ऑफ रूट्स अंडर सर्टेन कंडीशंस. Sometimes certain conditions are given to you and you have to form the roots under those conditions. One simple way to do is find the sum of the new roots and product of the roots, and you can write the equation. Say for instance, the equation whose roots are, you are given that this is your equation ax square plus bx plus c equal to 0, and the roots are alpha and beta. We have to form an equation whose roots are k alpha and k beta. So what will you do? K alpha plus k beta, you can find out. This is k times alpha plus beta. And you know, what is this? K times minus b by a. And k alpha into k beta. K alpha into k beta is equal to k square times alpha beta, and this is k square into c by a. So the required equation is x square minus sum of the roots minus kb by a x plus product of the roots. So what does this become? Ax square plus kbx plus k square c is equal to 0. This is the equation whose roots are k times the roots of this equation. What have you done? You have multiplied this by 1, this by k, and this coefficient by k square. This you can take it as if you are multiplying by k to the power 0. So the power of k and the power of x, if you add, it will always be 2. Yeah, k to the power 1 into x to the power 1. 1 plus 1 is 2. K square c into x to the power 0. And this result holds for polynomials not of only of second degree but of higher also. So rather than remembering doing all these calculations, if you just know the formula, it will be much simpler. Is that okay? Now when you say that you want negative, that means k is minus 1. K minus 1, but you can write the equation straight away. The equation whose roots are minus alpha minus beta is ax square minus bx plus c equal to 0. Reciprocals. So these are some of the results you will be needing. Now if you want this, number 4, that the roots are the squares. That means if x is a root of this equation, you want y, so that y is alpha square and y is beta squared. You want to form an equation whose roots are alpha square and beta square. So one way is you put y equal to x square in this equation. So what you will get is ay plus bx. Under root nahi likhenge. So your ay plus c is minus bx. Square both the sides. So you will get this whole square. And again you replace x square by y. So this will become b square y. And you simplify. Whether you write in an equation the variable as x or as y or t, does it matter? It doesn't. It's a dummy variable. Dummy variable means the name, I can give it to be anything. Rather than writing this equation, I can write it as ay square plus by plus c. Will the roots of these two equations remain the same? Isn't it? Because it depends on the coefficients, not on the name of the variable. So these are some of the results which will be useful to you. Now, let us come to the most important thing here is how to graph a quadratic equation. That is the most important thing in this chapter. If you know how to draw the graph, you will find that you will be able to do the questions very easily. You will understand them also, and you will be able to solve them. Sometimes doing them algebraically becomes very difficult. So what we have is ax square plus bx plus c. As I told you yesterday, what are we going to do? We'll complete the square. How do we complete the square? We'll first take out a common, and a is non-zero. We can divide by a, and this is x plus b by 2a whole square. This gives you x square plus this term minus b square by 4a square plus c by a. And this becomes this, we have called it D, right? Minus sign common alien. This is what it is. You've already read in class 10 that the curve This represents a parabola, ax square plus bx. Now parabola can be like this, or it can be in the other direction. Now how do we know which one it's going to be? That's the most important thing we have to decide. So this is what your fx is. And perhaps you have already read, you might be knowing that when does the parabola open upwards? When a is greater than 0. And it opens downwards when a is less than 0. What happens when a is 0? A cannot be 0. A is the coefficient of x square, so it cannot be 0. So that is why we are not considering that case. Now, how will you know? Do we have to remember this by heart? Sometimes we try, if we forget, isn't it? In 10th, maybe you just remembered it. Now I will just tell you how we can just see what it is going to be. For very large values of x, whether positive or negative, what happens? X square is very large as compared to x. So this term will behave like ax square, and c is just a constant. It doesn't affect the value that much. Supposing your x is 10 to the power 5, x square will become 10 to the power 10. That is very large as compared to bx plus c. So we can say that this term is really, it behaves like the term ax square. And x square is always positive. So this term is going to be positive or negative. That will depend on the value of a. If a is positive, this is going to be positive. And if a is negative, it is going to be negative. Right? Now your x-axis can be, so it is going to go from, when a is greater than 0, the value of this will go from plus infinity to again plus infinity as x changes from minus infinity to plus infinity. When x is very large and negative, this is still going to be positive, and as x is very large and positive, this is still going to be positive. So the shape of the curve will be this. Is that okay? And when xa is negative, this is going to be negative when x is very large, either positive or negative. So the shape is going to be like this. Is that clear? This is one of the most important points that we have. Now, where is it going to intersect? See, where is your x-axis going to be? Is the x-axis going to, is it going to be like this? Or is it going to be like this? Or is it going to be like this when a is positive? Let us take that a is positive. Let me draw it together. You can divide it into two parts. When a is positive and when a is negative. So the curve is going to be like this. And when a is negative, this is your parabola. The x-axis can be here. The x-axis can be here, just touching. Or the x-axis can be here, that it doesn't meet the x-axis. Similarly, here also, the x-axis can be here, the x-axis can be here, and the x-axis can be here. What does this mean? This means that it meets the x-axis in 2 points. And when will this happen? This will be when d is greater than 0. This, it meets it in? No, it meets it in 2 coincident points. The roots, remember, the roots of a quadratic equation are always 2. They may be equal. So here in this case, you will have d is 0. And this is when d is less than 0. It doesn't meet this is your x-axis. It doesn't meet the x-axis. So the value of fx here you can see is always negative. The value of fx here is always positive. And if you just see where we wrote, can you turn to the next page? इसके आगे, even further, beyond this. I think it's, yeah, page 4, graph of quadratic equation. So here we have distinct roots if we want to write in terms of roots. In both the cases, we have distinct roots, distinct real roots, equal roots, real roots. And here you have, in this case, complex roots. Is that okay? Now this is called the vertex of the parabola. In all cases, there is a vertex. Now let me just rub this off. And what we are always going to draw is either a parabola like this or a parabola like this. This is the shape. It's going to be this one, we say it's open upwards. This is when A is greater than 0, and this is when A is less than 0. Where are we going to draw the x-axis? Depending on whether D is positive, equal to 0, or negative, right? Just now we wrote, so axis of the parabola. If B is 0, then the axis, this line is called the axis. You will study it in more detail when you will do coordinate geometry, parabola, right? There also you will do. And if B is non-zero, then the axis is parallel to the y-axis. Now this is called the vertex, and the coordinates of the vertex are minus b by 2a and minus d by 4a. It doesn't depend on whether a is positive or negative. This is what the vertex of the parabola is. Point number 5, I've taken up these points. Now, when a is greater than 0, fx does not have a maximum value, but it has a minimum value. Minimum value is at the vertex, and it is minus d by 4a. And when a is less than 0, fx does not have a minimum value. It has a maximum value, and the maximum value again is at the vertex, which is the coordinates of the vertex are the same. So we are classifying according to two things, whether it is open upwards or open downwards. That just depends on the sign of A. Then the other classification is dependent on D. Whether D is greater than 0, equal to 0, or less than 0. So when you see, so this is what, so let us just see the sign of fx. We'll just write down, because this is going to be used a lot. What is our sign of fx? And what is our fx? Ax square plus bx plus c. And I will write it in a tabular form. A, then d, and what is fx? We'll take 3 cases. When a is greater than 0, you have 3 cases. D is greater than 0. You can just write. And what is the curve? The curve is going to be like this. So what do you have here? If these are the roots alpha and beta, what happens? Less than alpha, it is positive, and greater than beta also, it is positive. So what do you have? There are 2 roots. 2 roots, alpha, beta. Let alpha be less than beta. The smaller root, we are calling it alpha. So fx is greater than 0 for all x belonging to minus infinity alpha union beta infinity. Right? When D is equal to 0. In this case, what do you have? Fx is greater than equal to 0 for all x belonging to R. R is what? The set of real numbers. R is the set of real numbers. And when D is less than 0, you have, this is your parabola. So what do you have? Fx is greater than 0. In the second one, it can be, all these three cases are when A is greater than 0. You will have similarly when A is less than 0. You can focus on this. Wow. Is that okay? Now, shall I just change it here? When A is less than 0, then you will have similar cases. When A is less than 0, similarly, you consider D is greater than 0. And what will you have? Your parabola will be like this. Again, the roots are alpha and beta. Two roots, alpha, beta. Let alpha be less than beta. Then what do you have? Fx is, what is the value of fx? It is less than 0. Fx is less than 0 where? When x is less than alpha or greater than beta. So x belonging to minus infinity alpha union beta infinity. Right? When your A again is less than 0, but D is equal to 0. This will be the parabola. So you will have fx is less than equal to 0 for all x belonging to R. And when D is greater than 0, sorry, less than 0, then you will, this is the shape of your parabola. So you will have fx is less than 0 for all x belonging to R. Is that okay? So this, we should, whenever we have questions, we should try to draw the graph first depending on A, look at the value of A. So whether it is open upwards or open downwards, and then look at your value of D. Now let us come to some more theory, and then I'll take up questions. Purposely, I'm going to take up questions together so that you know what to apply. If I take up after every point, then you will obviously know that we have to apply just this point. So, page number 9, I think. Eight होगा, हाँ ये. Questions के आगे, beyond this. इसके आगे, next page, next page, next page. Constraints on the roots. This is what we are going to study now. Some of them we have already done yesterday, but for sake of completeness, I'm just repeating them today. Both roots have the same sign. That means both roots are either positive or negative. So the product of the roots will be positive, so A and C have the same sign. And discriminant, of course, should be greater than equal to 0. Here, when we are saying they have the same sign, they can both be positive or both be negative. If both are positive, then A and C have the same sign, and B has opposite sign. We discussed this yesterday. And when both are positive, then all A, B, C have the same sign. Then both the roots have opposite sign. Then product of the roots is going to be negative, so A by C will be negative, and that means that A and C have opposite sign. Now roots, point number 5 is, roots lie on either side of a real number K. This is what it is. This is your roots alpha and beta, and here is your k. This is when a is greater than 0. And what will it be when a is less than 0? This is your alpha, this is your beta, and this is your k. There is some real number k. One root is less than k and the other root is greater than k. So what do you have here? What is the value of fk in this case? Fk is going to be negative. Here fk is going to be positive. D has to be greater than 0 if there are two roots. So D is great. So what is the product? A into Fk. AFK has to be, A is positive, Fk is negative. So AFK has to be less than 0. Here also, AFK has to be less than 0. So in both the cases, AFK has to be less than 0. So if this sort of condition is given, that roots lie on either side of a real number, all that you have to apply is that A into Fk should be less than 0, and the discriminant, of course, has to be greater than 0. Now both the roots are less than k. You can just leave it. We are saying both the roots are, so I'll just change this. Where is your k here? So what do you have here? Here you have Fk is greater than 0, and here you have Fk is less than 0. So what about AFK? AFK has to be greater than 0. In both cases, you are having AFK is greater than 0. A is negative, Fk is also negative, so their product is going to be positive. Now another thing, alpha is also less than k, and beta also is less than k. Both the roots are less than k. So what is alpha plus beta? This is less than 2k, and alpha plus beta is minus b by 2a, minus b by a. Alpha plus beta is minus b by a. This is less than 2k, and this gives us that minus b by 2a is less than k. Is that clear? अब ये याद करना पड़ेगा? नहीं, कैसे याद रहेगा? हर बार ये कैलकुलेशन करेंगे? नहीं, ये देखो माइनस बी बाई 2a क्या है? वर्टेक्स है ना यहाँ, वर्टेक्स का x कोऑर्डिनेट. What are the coordinates of the vertex? Minus b by 2a and minus d by 4a. K has to lie on the right hand side of the vertex. That means minus b by 2a is less than k, or k is greater than minus b by 2a. So there are two conditions. That d is greater than equal to 0, AFK is greater than 0, and minus b by, point number 6, minus b by 2a is less than k. Now, is that okay? If both roots are greater than k, तो क्या होगा? ये k इधर आ जाएगा, isn't it? And you will have Fk is again, condition on Fk remains the same. Fk, ये ऐसे parabola आएगा ना. So again, this condition will remain the same. That AFK is greater than 0. But what happens to the roots? Here you will get alpha is greater than k and beta is greater than k. Both the roots are greater than k, so the sum will be greater than 2k. So you will have minus b by 2a is greater than k. That means k is on the left hand side of the vertex. So if you just draw the graph, you will find it's very simple. What did we do? एक बार बीच में लिया था k. That means roots were on either side of k. अब हमने one side लिया था, both on the right of k or both on the left. Now what we can have, is this clear? Just read it. I'll just rub this off. Both roots lie between k1 and k2. That means this is the curve. Here you have k1, here you have alpha, here you have beta, and here you have k2. And the other way it will be like this. Alpha, beta, k1 and k2. A is less than 0 and A is greater than 0. So what happens to fk1? fk1 and fk2 both are greater than 0 in this case. And here fk1 and fk2 are less than 0. So A times fk1 and A times fk2 both will be greater than 0. So you have A fk1 and is greater than 0 and A fk2 is both greater than 0. And where is the vertex? Vertex is in between k1, k2. Or you can say, you can apply that condition as we did before. K1, both the roots are less than k1 and both the roots are greater than k2. So you will get that k1 is less than minus b by 2a is less than k2. So these are the three conditions that need to be satisfied. Okay, is that okay? All right. Now let us come to exactly one root is between k1 and k2. Exactly one of the roots is between k1 and k2. So what is the graph going to be like? So if we have here where a is greater than 0, this is your k1, this is your k2, and these are the roots alpha and beta. Or it can be like this, when you have alpha, beta, and here can be your k1, and here can be your k2. The root alpha can be between k1, k2, or the root beta can be. Similarly, for this, you will have k1, k2, this is alpha, this is beta, this is a less than 0. Here also you have a greater than 0. Or it can be like this. Alpha, beta, k1 and k2. So what are the conditions that you will get? Here fk1 is greater than 0 and fk2 is less than 0. Here also fk1 is less than 0, fk2 is greater than 0. So the product fk1 into fk2 is less than 0. Here also you will find that fk1 and fk2, their product is also less than 0. So in this case, you will have that fk1 and fk2 will be less than 0. Now, this condition that d is greater than equal to 0 will hold automatically. Why? Because when we are having fk1, when you have a continuous function, and at one point the value is greater than 0, at another point the value is less than 0. You have to reach from here to here. कैसे जाओगे? Continuous function का क्या मतलब है? You can draw the graph without lifting your hand from the paper, pencil from the paper. So how will you do it? You have to intersect the x-axis. Whether you're going from top to bottom or from bottom to top. We have not talked about continuity, but polynomial functions are continuous functions. In fact, you will do this result. If f is a continuous function such that fa into fb is less than 0, then fc will be equal to 0 for some point c between a and b. This is what we are saying. The function value here into the function value here is less than 0. They are of opposite sign. So at some point in between them, it will be equal to 0. You will do in differential calculus. We are just applying it to polynomials. We know that they are continuous functions, right? So that is why, again, this is another result which you can always assume that if at one point it is greater than 0, another point it is less than 0, or vice versa. That means the product is less than 0, that at some point it will be 0. And last point, and then we'll do some questions, is that the K1 and K2 lie between the roots. K1 is also here. And here you have K1 and K2. So what do you have here? The 2 points K1 and K2 are between the roots. When you're having roots, this means the discriminant has to be greater than equal to 0. So what do you have? A is positive. Here A is negative. पहले ये केस किया है ना, K lies between the roots. तो वहां what was the condition? AFK is less than 0. तो यहाँ पे क्या आ गया? AFK1 is less than 0 and AFK2 is less than 0 in both the cases. AFK1 is less than 0 and AFK2 उसी से आ जाएगा, is less than 0. Is that okay? बहुत सारे theory हो गई. And as I told you, this is the most important thing in quadratic equations. The rest is important, we will use it, but doing it graphically and solving, this is the most important. Now we'll take up questions. So, इससे पहले आगे पेज है शायद, हाँ, इससे भी आगे. नहीं, before 8. Questions. Questions are on page 8, I think. इससे भी पहले. हाँ, we'll take up question number 10. We have done question number 27. Question number 27. What does it say? If fx is equal to x square plus 2bx plus 2c square and gx is this, such that minimum of fx is greater than maximum of gx, prove this result. Now let us see. Just draw the graph, a rough sketch. For fx, what will it be? Open? Open upwards. Coefficient is 1. It's positive. So this is your fx. And Your gx will be this. So what is this point? Here you will have a minimum. So minimum of fx. Fx is what? X square plus 2bx plus 2c square. So minimum of fx is equal to minus d by 4a. Where d is the discriminant, calculate this value. And gx is and maximum of gx is equal to minus d by 4a here. This a here is minus 1. It's not the same a. It's with reference to fx and g. So just calculate what is minus d by 4a. What is the value that you get? B square minus 2c square. And gx? Is everybody here minus sign लिया है? This is incorrect. ये आएगा. This is 2c square minus b square. And what is for gx? B square plus c square. This is b square plus c square. So according to the given condition, what do you have? 2c square minus b square is greater than b square plus c square. So c square is greater than 2b square. So mod c is greater than root 2 mod b. Modulus function बहुत important है. You must know all these results in inequalities. Basically, this is one formula that you are using. That's all. For this question, we are just using the fact that if a is greater than 0, the curve is like this, and this is the minimum value, and it is this. And if a is negative, the curve is like this, and at the vertex. This is called the vertex of the parabola, and we know the coordinates. So now let us come to question number 25. Find the least integral value of k for which this equal to 0 is positive for all x. Least integral value of k such that this is, first of all, what you have? That a should be positive. Just try the question. A should be non-zero, not positive. A should be non-zero. We are doing question number 25. If we want, see the curve, will it be like this or like this? When is fx always greater than 0? When it is open upwards, right? And when is it open upwards? So this is not what we want. When a is positive and d is negative. Because if your if it is open upwards, there can be, if it is here, then it is not always positive. If it is your x-axis is here, then also it is 0. So if we want positive, this is what the situation is. So we have two conditions: A is greater than 0 and D is less than 0. A greater than 0 means k minus 2 is greater than 0. That is, k is greater than 2. This is your first condition. Just write down the second. B square minus 4ac is less than 0. So this is b square minus 4 times k plus 4 into k minus 2. This is less than 0. And what will this give you? And this gives you minus k squared minus 2k. Just do it. Factorize जैसे कल बताया था. क्या करना है? 24. How will you break it this up? 6 and 4. 6 4s are 24. So k minus 6 into k minus, यहाँ minus 24 आएगा. You need a plus sign here and minus, so these are going to be of opposite sign. I just write both minus. Minus को plus बनाना बड़ा आसान है. एक डंडा लगा दो. इन दोनों के साइंस ऑपोजिट होंगे, पर इनको ऐड करोगे तो प्लस होना चाहिए. So this is how you will factorize it. Also, what are we getting? K is greater than 2. So here you will get that k minus 4 is. Both are positive or both are negative. They can't be negative because k is greater than 2. So you can't have k less than 4. So k is greater than 4. You want k to be greater than 2 and greater than 4. If you just read the question, find the least integral value. What is the least integral value? Greater than 4. यहाँ 4 है, यहाँ 2 है. We want that k should be greater than 4, not including 4. So the value is 5. So the least integral value is 5. Don't go by that. I've written the answer there already. Right? Is that okay? You want k to be greater than 4 and you want the integral value. अगर rational चाहिए होती तो बता सकते थे. There are infinite number of rational numbers. So just greater than 4, you can't say which is the rational number, but you can say which is the integer. Right? So after 25th question, let us come to question number 14. Question number 14. Yes. If A, B, and C are real numbers, just read the question. Question number 14. If A, B, C are real numbers and alpha, beta are the roots of this equation, where alpha is less than minus 1 and beta is greater than 1. So if you just see, your alpha is less than minus 1. This is what it is. Alpha is less than minus 1 and beta is greater than 1. This is what it will be when A is greater than 0. दूसरी possibility क्या है? A is less than 0. This is your alpha and this is your beta. So you will have alpha is less than minus 1 and beta is. So what are the condition? Last वाली जो अभी use की थी हमने, between K1 and K2. Right? So what you have is, just apply it. So what do we have? That the roots lie between -1 and 1. Roots lie between -1 and 1. So you have a f of -1 and a f of 1. What is your a? Both have to be less than 0. So apply these two conditions. AF of -1 is less than 0 and AF of 1 is less than 0. AF of -1 is what? Less than 0 implies A into A plus A minus B plus C is less than 0, and AF of 1 is less than 0 implies A into A plus B plus C is less than 0. Is that okay? Now divide by A square. See, when we have to divide in inequalities, you have to be very careful. First of all, we can never divide by 0. And if it is an inequality, the sign of the inequality changes. Is that okay? So we divide by A square. A square is always greater than 0. So dividing both of them by A square, we have 1 minus B by A plus C by A is less than 0, and 1 plus B by A plus C by A is less than 0. Divide by A square. What does this mean? Only the sign of B by A is changed here. So you can say here 1 plus C by A plus mod of B by A is less than 0. Mod B by A is either B by A or minus B by A. And this is precisely what we had to prove. Just look at question number 13 now. Question number 13. It says that alpha, beta are the roots of this, and one lies between alpha and beta. One lies between the roots. So we have to find the value of A. What is the condition? The first one which we used today, number 4 or 5, whatever. K lies between alpha and beta. Here, what is the graph going to be? A is positive. It's going to be upward. If you don't remember the conditions, just try to draw the graph. One lies between the roots. This is 1. So what do you have? A is greater than 0. A times F1 is negative. A is 1. So F1 is, this you should understand, this is the usual meaning. This is coefficient of x square. Because here A is having a different meaning in this question. A is used as the constant term. So it is not the same A. So the condition is coefficient of x square into F1 is less than 0. And coefficient of x square is 1. So what does this give you? 1 minus 3 plus A is less than 0, which implies A minus 2 is less than 0. And this implies A is less than 2. So simple. And you can just see if you draw the graph सीख लो quadratic equation का. Oh, दो चीजें open upwards or open downwards. And then where does it intersect? Depending on D. Both are independent of each other. Right? Now let us take question number 16. It's there. Prove that the equation 1 by x plus 1 over x plus a plus 1 over x minus b equal to 0, where a, b are greater than 0, has two roots, one in each of these intervals. First, write it as a quadratic equation. Take the LCM and make the quadratic equation out of it. I'll just give you 2 minutes for that. It will be x plus a into x minus b plus x into x minus b plus x into x plus a is 0. Now सारी terms मत खोल खोल के लिखो 4 plus 4 plus 2 plus 2 नहीं. Can you collect terms? You know how to do them? x square की term देखो हर एक में. This is x square x square x square. कितना हो गया? 3x square सीधा. ठीक है? प्लस x की टर्म अगर ज्यादा है नहीं लिखा जा रहा. a minus b plus a. That's all. Then minus ab. Constant term सिर्फ यहीं से आएगी ना. So this is 3x square plus 2 times a minus b. This is what your equation is. So this is your fx. Let fx be equal to this. What do we have to show? That fx has a root in which interval? Let us take the first interval, minus 2a by 3 and minus a by 3. What does it mean? That f of this into f of this should be less than 0. Then only it will have a root in this interval. So, therefore, we must have f of minus 2a by 3 into f of minus a by 3 must be less than 0. Just calculate. Calculate the values of f of minus 2a by 3. Just substitute here. And f of minus a by 3. And just, this is what we should have. Just calculate the two values. This value turns out to be f of minus 2a by 3 into f of minus a by 3 is equal to minus a square b over 9 into a plus b when you simplify it. Now, are all these terms going to be positive? A square is positive, but a plus b and b may not be. So, but if you read the question, a and b are given to be greater than 0. So this is less than 0 because a and b are positive. So this is less than 0, so there is a root in this interval. Right? The other condition you will again check that f of b by 3, this is just simple calculations, into f of 2b by 3 is also less than 0. In fact, when you find this out, you will get this to be f of b by 3 into f of 2b by 3 is minus ab square by 9 into a plus b. You can check this is the value you will get. Right? And so which is less than 0 because a and b are positive. So fx has a root, therefore fx has a root in b by 3 and 2b by 3. Let us take up the next question, question number 19. For what real values of a do the roots of this equation have unequal roots for all real values of b? Just read and understand the question. Question number 19. For what real values of a do the roots of this equation have unequal roots? The roots are unequal, that means discriminant is greater than 0. So just calculate. Roots are unequal means d is greater than 0. And what does that give you? A minus b whole square minus 4 times 1 minus a minus b is greater than 0. This has to be true for all values of b. So simplify this and write it as a quadratic in b. Something times b square, and this is the constant. When you simplify this, just simplify it. बी स्क्वायर की टर्म तो सिर्फ यहीं से आएगी. बी का कोफिशिएंट क्या आ रहा है? बी का 4 minus 2a with a sign positive, and then plus 4a minus 4 plus a square. That means we can rewrite it as b square minus 2 times a minus 2. I like to write my constant later on. And I like to write this, so I write it here, and with the coefficient of a I want, I like to write it this way. You can write it whichever way you like. It's the same thing. This is what we want. So when will this hold? This is a quadratic in B. When will this be greater than 0 for all B? You can look upon this as a quadratic in B. Discriminant, this is open upwards. So discriminant should be less than, it should not intersect. So discriminant of this, if you look upon it like this, x square minus 2 times a minus 2 times x plus a square plus 4a minus 4. This has to be greater than, we want fx should be greater than 0 for all x. Isn't it? Instead of b, I've just written x. Fx should be greater than 0 for all x, and the condition for this is that the discriminant of this fx should be less than 0. This holds when, I'm not writing d again, wahan d likh diya, discriminant is less than 0. So just write the discriminant of this. Writing this in this way, is that clear or not? Is there any confusion? Because B is, this is what we are saying. If you are not happy with this, you can write B. So you will say FB. As I told you, X is a dummy variable. It doesn't matter what name you give it, right? So this is, so write the discriminant of this. सिर्फ 32 आ रहा है. Calculation mistake. B square plus minus 4ac. So it will become 8 times a minus 2 into a square a square plus 4a minus 4. So just simplify. A should be greater than 1. What do you get when you simplify this? You get minus 8a plus 8. Or you get 1 minus a is less than 0. Which gives us a is greater than 1. Okay? So does the graph help? Otherwise you can't remember the rules. They are very confusing. I mean, I've given you 10 of them. Isn't it? So if you just draw the graph, it will be much easier to see. Now let us take up question number 15. ये सारे बड़े simple questions थे. This is a slightly difficult question. Not very difficult if you know the techniques. Question number 15 says A is less than B is less than C is less than. A, B, C, D are 4 numbers such that A is less than B is less than C is less than D. Then we have to prove that for any real number K, this will always have real roots. When will it have real roots? When D is greater than or equal to 0. So you can just write the discriminant and apply the condition that it is, you have to prove that it is always greater than or equal to 0. But you will find that that's very tedious. So we are going to do it another way. That's one of the ways, right? So you can try that. I'm not going to spend time here. Write the discriminant, write it as a quadratic in D, in X, and write the discriminant and apply, simplify it, and you should be able to prove that it is always greater than or equal to 0. So that means you are able to write it as sum of positive numbers or something like that, product of some numbers which are always positive, and that's not an easy thing at times. But what we will do is we will use another way and you will find the elegance. Now what we are going to do is we will take 3 cases. Case 1, what can K be? We are saying that for any real number K, this should always have real roots. So whether K is 0 or greater than 0 or less than 0, if in all the 3 cases we can prove that the roots are real, then we are done, right? So let us do that. Case 1, K is greater than 0. So when K is greater than 0, what does your fx become? Fx is x minus a into x minus c. And this has fx equal to 0, has real roots, isn't it? And what are the roots? A and C. Not only we have got that they are real, we have got the roots as well. So this method will give you a slight location of the roots. Here you have got the exact roots. But when we'll consider the other cases, K is greater than 0 and K is less than 0, you may not get the exact roots, but you'll get the location. So case 2. So before doing case 2, let me calculate what is your FA, because I will need this. What is your FA? K into A minus B into A minus D. FB is X minus B minus A into B minus C. FC is K times K minus C minus A into C minus D. And FD is equal to D minus A into D minus C. This is not dependent on K. Can you tell me whether it is positive or negative or what? FB, B minus A into, so this is positive, this is negative, so this is always less than 0. What about D minus A into D minus C? This is positive, right? And this, what is C minus A? Positive, and C minus D? Negative. So their product is going to be negative. So K into negative. It will depend on K, whether K is positive or negative. And this will be K into A minus B is negative and A minus D is negative. So this is K into something positive quantity. With this, it will help us to simplify. Now, case 2. After this, K is positive. When K is positive, what is FA? FA is greater than 0, FB is less than 0, FC is less than 0, and FD is greater than 0. Now, if you just look at this, this is your number line. A, B, C, D are somewhere here. Right? FA is positive, FB is negative. So we are going to come somewhere here. And then FC is again negative, FD is positive. This is what the curve will look like. K is positive. It will be open upwards or downwards. What is the coefficient of x square? 1 plus k. K is positive. So 1 plus k is positive. So the parabola is going to be open upwards. Otherwise, also you can say from here, FA and FB is less than 0 implies fx has a root in the interval AB. यहाँ से भी algebraically भी कह सकते हैं. यहाँ से मैंने ये ग्राफ बना लिया. There is a root between A and B. There is a root between C and D. So it has real roots. FC into FD is less than 0 implies fx has a root in C, D. So it has real roots. And what does it say? There is one root between A and B, and there is another root between C and D. It's so simple. Not only have we said that it has real roots, we have also found the location. You try to do it by the other method, you will see the difference. So that's why, I mean, if you appreciate mathematics, you'll say this is a very elegant way. It has an elegant solution. Okay. This is the case when k is greater than 0. Now let us take the case when k is less than 0. Case 3, k is less than 0. What can we say about FA? FA is less than 0. FB is, it doesn't depend on K. FC is greater than 0. And this is greater than 0. There is only one change of sign between B and C. Now I don't need this. So now the coefficient of x square is 1 plus k. 1 plus k, when k is negative, 1 plus k can be positive or negative. So if 1 plus k is greater than 0, not only that k is negative, but 1 plus k is greater than 0. We have the points A, B, C, D. FA is less than 0, FB is less than 0, FC is greater than 0, and FD is less than 0. So what is the curve going to look like? It's going to open upwards. 1 plus k is greater than 0. तो यहाँ से चलेगा. FC is greater than 0. This is what it's going to be like. FA is less than 0, FB is less than 0, FC is positive, FD is also positive. So there is a root between B and C. यहाँ से भी कह सकते हैं. There is one root. What about the other root? Other root will be less than A. The other root will be less than A. The other root. It's to the left of A. Is that okay? Now, the other case, this is K less than 0, but with 1 plus K positive. Right? Now we have to have 1 plus K negative. जब 1 plus K negative आएगा, तो क्या होगा? The parabola is going to open downwards. ऐसे बनेगा. FA is less than 0. FB is less than 0. FC is great. एक root B और C में lie करेगा ही करेगा because of this. It is about the other root. So, it's going to be like this. This is what the parabola will be. 1 plus K is less than 0. There is one root between B and C. The other root will be greater than A. Order हमने ये दिया है इसलिए ऐसे लगा दिए points. So one root between B and C, that we can say straight away from here. Whenever K is less than 0, there is one root between B and C. It's about the other root which is dependent on how the parabola is opening. Is that okay? And the other root is greater than D. Just you can go through it for 1 or 2 minutes if you like, because this is using a lot of your concepts. We'll do question number 18 after this. For what real values of A does the equation x square minus 2x minus a square minus 1 equal to 0? थोड़ा सा इसमें language में problem है. Do the roots of the equation. Do the roots of the equation. I corrected it, I think. नहीं हुआ. For what real values of A do the roots of the equation? इसको जरा highlight करना, please. This one. You have to write do the roots of the equation. Does the equation do the? This is, I'll just write the, for what real values of A do the roots of the equation language में थोड़ा सा 2 words छूट गए हैं. Do the roots of the equation x square minus 2x minus a square minus 1 equal to 0 lie between the roots of the equation x square minus 2 times a plus 1 into x plus a into a minus 1 equal to 0. So let us first find what we have if the roots are alpha and beta. If the roots of this equation are alpha and beta, they have to lie between the roots of this equation. So let us see what are the roots of equation 1. This is 1, and this is 2. Step 1 is find roots of 1. कैसे करोगे? फॉर्मूला लगाओगे? माइनस बी फटाफट वही लगाते हैं ना, फैक्टराइज की कोशिश नहीं करते. इसके क्या फैक्टर्स बनेंगे? a minus 1 into a plus 1. एक जगह आएगा a minus 1 और एक जगह आएगा a plus 1. इनका सम -2 हो सकता है इन दोनों का. इनके साइन ऑपोजिट होंगे तभी तो यहाँ माइनस साइन आएगा ना. तो इनके साइन तो ऑपोजिट होंगे. इनको ऐड करके तो नहीं होगा, सब्ट्रैक्ट करके नहीं आ सकता. a minus 1 और a plus 1 आएगा. When you subtract them, you will get -2. So a minus 1. शुरू में दिक्कत लगेगी, but if you practice this, you will be able to write it very fast. So this is what the factors are. You can check x square minus a square minus 1 और इन दोनों को ऐड करो. a minus 1 minus a minus 1. So -2. So the roots are, therefore x is equal to a plus 1 and a minus 1. Call them lambda 1, lambda 2c. Now let us, what do we want? We want that these values should lie between the roots of this equation. Equation number 2. What is a? Coefficient of x square. 1, positive, open upwards. So the figure we'll make is this parabola will open upwards. Right? This will open upwards if its roots are alpha and beta. This lambda 1 and lambda 2, where should they lie? Between alpha and beta. Lambda 1 and lambda 2. कौन सी condition थी? Last वाली. That lambda 1, lambda 2 lie between alpha and beta. So lambda 1 and lambda 2 lie between the roots of equation 2. This is your graph of 2. So what is the condition? A तो 1 ही है. F of lambda 1 and f of lambda 2, they are both, यहाँ से भी दिख रहा है. अगर ये ग्राफ करेक्टली बनाया है तो क्या है? f of lambda 1 का क्या साइन है? नेगेटिव. f of lambda 2 नेगेटिव. a पॉजिटिव है, a equal to 1 है इसलिए. Otherwise you have a times f of lambda 1 should be negative. Is that okay? तो ये कंडीशन लगानी है. lambda 1 की वैल्यू यहाँ डालो, f of lambda 1 निकालो. Just find out f of lambda 1. This we are calling it fx. Step 2. Let fx be equal to this, and this is your graph of fx. So f of lambda 1. F of lambda 1 is equal to f of a plus 1. Just simplify. What is the value? This is a plus 1 whole square minus 2 times a plus 1 whole square plus a into a minus 1. क्या वैल्यू आ रही है? माइनस ए प्लस 1 होल स्क्वायर प्लस a into a minus 1. Just simplify this. Minus 3a minus 1. So f of lambda 1 less than 0 implies minus 3a minus 1 is less than 0, which implies 3a plus 1 is less than 0. Nahi. Inequality in inequalities, when you multiply by a negative sign, the sign of the inequality is reversed. When you multiply by some number which is positive, it remains the same. So it will be greater than 0, and which implies a is greater than minus 1 by 3. Now f of lambda 2 is again less than 0. You can write it straight away. F of a minus 1 is less than 0, and this implies is a minus 1 whole square minus 2 times a plus 1 into a minus 1 plus a into a minus 1 is less than 0. So when you simplify this, you simplify it. रूट्स एक बार चेक करना, हमने क्या इक्वेशन लिखी थी जो फैक्टराइज किया था. व्हाट वर द फैक्टर्स? x माइनस जो बिल्कुल जो रूट्स निकाले थे लैम्डा 1 लैम्डा 2 इनटू a माइनस 1, और हमने रूट्स क्या लिखे थे? x इज a प्लस 1 एंड a माइनस 1 नहीं है, माइनस ऑफ a माइनस 1. हाँ, क्योंकि यहाँ सारा a स्क्वायर कैंसिल आउट हो रहा है. That is not correct. So it is minus of a minus 1. So this will be, यहाँ फर्क नहीं पड़ेगा, यहाँ फर्क पड़ जाएगा, ये माइनस प्लस बन जाएगा. Is that okay? The roots are not a plus 1 and a minus 1. They are a plus 1 and minus of a minus 1. Just make this correction. Lambda 2 is minus of a minus 1. So here this will be a positive sign. So this will give you 4a square. A square cancel nahi hoga. You will get 4a square minus 3a +3 नहीं, +1 -2, तो -1, यहाँ से +1 आएगा और यहाँ से -2 आएगा. This is less than 0. 4a square. Now can you factorize it? यहाँ देखो a का कोफिशिएंट नॉन जीरो है, दोनों के साइन नेगेटिव नहीं होंगे. मैंने वैसे ही नेगेटिव, एज आई टोल्ड यू, एक पॉजिटिव बनाना बहुत आसान है. -3a चाहिए तो -4a + a, ये इसके फैक्टर्स बन जाएंगे. 4a + 1 into a - 1 is less than 0. So they are of opposite sign. So what do you get? मैं इसको थोड़ा ज्यादा डिटेल में, एक हमारे पास पहले कंडीशन आ गई है, a is greater than -1/3. If you just see here, this is your 0, this is your -1/3. 4a + 1 is less than 0 and a - 1 is greater than 0. Either you have this or 4a + 1 is greater than 0 and a - 1 is less than 0. What does this give you? A is greater than 1, यहाँ 1 है, and less than -1/4, ये नहीं हो सकता. A is greater than 1 and less than -1/4. It's not possible. So this we will just get that 4a + 1 is greater than 0 and a - 1 is less than 0. The other condition is not possible. दोनों लिखवाई है मैंने इस बार, सीधा हम एक ही लिख देते हैं. It's not that we are not considering it. The other condition is not possible. This condition is not possible. So what do you have? That a is greater than -1/4 and a is less than 1. That means -1/4 is less than a is less than. सीधा भी लिखना आ सकता है, आना चाहिए. a is greater than -1/4, यहाँ आएगा. यहाँ ये कह रहा था a is greater than -1/3. Here it is saying a is greater than -1/4. So combining these two results, what do you get? -1/4 is less than a. Both should hold. We are looking at this. Don't think कि इसी को हमने देख के कहा है. A has to be greater than -1/3 as well as -1/4. तो यही वाला होगा ना? Is that okay? So this is the condition on A. Now let us take question number 20. Question number 20. If alpha is a root of this equation, ax square plus bx plus c equal to 0, and beta is a root of minus real root, both are real roots, show that there is a root gamma of this equation which lies between alpha and beta. So just write simple, alpha is the root of that equation. So what will you have? A alpha square plus B alpha. ये तो लिख ही लेते हैं ना जितना हमें पता है. And beta is a root of that equation. Minus A beta square plus B beta plus C. These two results will hold. What it says is that we have a root of this equation, fx, which is a by 2 x square. That a root of, if gamma is a root here, it lies between alpha and beta. That means what? We have to prove that f of alpha, if you have that f of alpha is here and f of beta is here, then naturally fx will intersect. So basically, we have to prove that f alpha into f beta is less than 0. It doesn't matter whether a is greater than 0 or less than 0. See, if you have your alpha here and beta here, if it is open upwards, this means it's going to be like this. This is the portion of the curve. Or it can be like this. It can be like this, or it can be like this. Ye gamma hai. We are just assuming for convenience, one root has to be less than the other, so alpha is less than beta, right? So the curve will either go like this or it will go like this. This is when A is positive. When A is negative, it will either be like this. This is your gamma. Or it will be like this. This is your gamma. Isn't it? ऐसे बनेगा या ऐसे बनेगा. But it doesn't matter what are the possibilities. In all cases, you will get that f alpha into f beta has to be less than 0. This is all that we have to prove. We need to prove. If we prove this, the result will be proved. Is this clear to you? That f alpha into f beta is less than 0. So just calculate what is f alpha. F alpha is a by 2 alpha square plus b alpha plus c. In alpha, the coefficient here is a, not a by 2. तो ऐसे हम लिख सकते हैं. b alpha plus c तो है ही. a by 2 बनाने के लिए हमें क्या करना होगा? मेरे को ऐसे लिखना है इसको. a पूरा ले लिया तो माइनस a by 2. सिंपल. यही तो करना पड़ेगा ना. b alpha plus c तो ले ही लिया. So this will be equal to this. And this is nothing but 0. So this becomes using 1. Right? Now, let us calculate what is f beta. F beta is a by 2 beta square plus b beta plus c. And this I want to write it as minus a beta square plus b beta plus c. इसको क्या लिखेंगे? +3/2a बीटा स्क्वायर, तभी a/2 आएगा ना, -1 + 3/2, and this is nothing but 3/2 a beta square. 3/2 a beta square. Is that okay? Now calculate f alpha into f beta. So f alpha into f beta, therefore f alpha into f beta, this is equal to 3/4 a square alpha square beta square with a negative sign. This into this. 3/4 a square alpha square beta square. And is this negative? A sub z squares, which is less than 0. So you have proved the result. So there is a root of that equation between, so fx has a root between alpha and beta. You know, you don't have to do the calculations in so much detail. This we are just doing elementary, and in the beginning you can practice. Once you have seen it, ये सब लिखने की जरूरत नहीं है, because you have objective type questions. So you need to do your calculations a bit fast. But in the beginning, maybe it will help you to write the solution in detail so that you remember. And slowly you can use shortcuts. Right? Okay. Then let us come to question number 30. Yes, 30. Let a and b be two real numbers. This is x square. If the roots of x square minus ax minus b equal to 0 are less than 1 in modulus, find the conditions on a and b. You know how this is made into an objective type? Conditions दी हुई होंगी various. 3 conditions आई है ना, तीनों अलग अलग choices दे दिया. Fourth is all of the above. एक choice दे दी mod b less than 1, दूसरी दे दी a plus b less than 1, तीसरी दे दी b minus a is less than 1, या a minus b is greater than -1, and fourth choice is all of the above. So that is how all these questions are converted to objective type questions. So let us see what are we going to apply here. The equation is x square minus ax minus b. The roots of this equation, supposing we assume them to be less than, alpha and beta, and we have to prove that, and we are given that mod alpha is less than 1 and mod beta is less than 1. That means the roots lie between -1 and 1. The roots lie between -1 and 1. So what will you have? The curve is like this. It will just open upwards. What is your A? A is 1, which is greater than 0. Coefficient of x square. Another thing you should be careful. I have purposely used these here, A, B, C here. This is how they are used in exams. It's not necessary जो भी A देखा हो. Coefficient of x square. Okay? And what we are saying, that if the roots are less than 1 in modulus, so the roots are between -1 and 1. तो -1 और 1 कहाँ होंगे? यहाँ. ये अल्फा बीटा है. -1 और 1 इनके बीच में होंगे, या अल्फा बीटा -1 और 1 के बीच में होंगे. ये हो सकता है,
सेकंड वाला होगा,
not this, right? So this is what you are having, that this is what it is going to be. So you can have, this is your K1, your last condition की थी एक, K1, K2. The roots are lying between K1 and K2. So what will you have? The sum of the roots is alpha plus beta is equal to A, and alpha beta is equal to minus B. This is what you have. Now what is mod of alpha beta? Mod of alpha beta is mod B, and mod B is mod alpha into mod beta, which is less than 1. So one condition which you get is mod B is less than. What is the other condition that you get? F of minus 1 and f of 1 are less than 0 or greater than 0? Figure greater than 0. ये दो conditions और चाहिए. F1 is greater than 0 and f of minus 1 is greater. So just write down. What does that give you? This implies 1 plus A minus B. B minus A is less than 1. ये इन टर्म्स को उधर ले जाओ. या ऐसे भी लिख सकते, you have to just see what your choices are. This is what the condition is. From the choices, you write it accordingly. Or it might be f minus b is greater than minus 1 likha. I don't know. Okay. Then f1 is greater than 0. F1 is greater than 0. What does this give you? 1 minus A minus B is greater than 0. And this gives us A plus B is less than 1. जो आंसर लिखा उस फॉर्म में I have just put the conditions, but the conditions can be, as I told you, in any other form also. Now let us take up question number 21. For A less than equal to 0, determine all the real roots of this equation. We did similar question on modulus yesterday. So you can just try this. What are you going to do? You are going to have two cases. Minus 3a square. A is less than equal to 0, it is given. So case 1 is x minus a is greater than equal to 0. So that is mod of x minus a is equal to x minus a. So what is the equation? The equation is x square minus 2a into x minus a minus 3a square is equal to 0. अब ये फैक्टराइज होगा जी, वील हैव टू सी कि कब फैक्टराइज करना है. यू हैव टू मेक टू फैक्टर्स ऑफ 5 whose sum is -2a, 5a square के 5 के 2 फैक्टर्स बनाने हैं कि सम, which is not possible because 5 is prime. Factors are just 1 plus minus 1 plus minus 5. तो इसलिए इसके सीधे रूट्स हम लिखेंगे. So what is your x? Just write down what are the roots. Just write down the roots. दो रूट्स आएंगे. Apply the condition that a is less than 0. ठीक नहीं है +5a square -a square आएगा. ठीक है. So just write down the roots. So what are the roots that you are getting? What are the roots? Finally, a into 1 plus minus a root 2. Root 2 आएगा ना सिर्फ. So this is a into 1 plus root 2 and a into 1 minus root 2. A is less than 0. So which root will you take? Here we are taking x is greater than a. A is less than 0 तो है. ये नेगेटिव होगा. रूट 2 is 1.4. तो ये वैल्यू लेस देन 0 और ये भी लेस देन 0. तो ये पॉजिटिव आएगा ना. So the root which we have to take is x is equal to a into 1 minus root 2 because a is less than 0 and x is greater than equal to a. A less than 0 दिया ही हुआ है. Now take the second case. X minus a is less than 0. So therefore the equation is x square minus 2a into minus of x minus a. So this will become plus. यहाँ पर 5 आएगा. So now find the roots. Equation is so what do you get x to be? Just do it. X is yes, a into root 6. So this is a into minus 1 plus root 6 and a into minus 1 minus root 6. ये तो negative है and a is also negative. So this will become positive. But x has to be less than a. ये greater than a हो जाएगा. So what is the root that you are going to take? Minus 1. Therefore, x is equal to minus 1 plus root 6 because x minus a is less than 0 and a is negative. So these are the two roots. So the roots are a into 1 minus root 2 and a into minus 1 plus root 6. Is that okay? Next page, please. Questions के बाद वाला. Yes. I'll give you some more results. You can just call them tips or whatever. Fx equal to 0 is a polynomial equation and p and q are two real numbers such that p is less than q. Without any loss of generality, one of them will be less than the other. So we are taking p less than q. If fp into fq is less than 0, सिर्फ पहले फर्स्ट वाला ही दिखाओ, थोड़ा नीचे कर दो, हाँ और नीचे, नहीं नहीं अदर डायरेक्शन में, और हाँ ओनली दिस. If fp into fq, we have been using it, is less than 0, then fx equal to 0 has odd number of roots between, थोड़ा ये भी आ जाए ना साइड वाला, हाँ, yeah. Here as we said, p and q. If fp into fq is less than 0, here it is positive. Say, there are two possibilities, fp is positive or negative. So what we are saying is that if this is your curve, so you will have a odd number of roots between p and q. If this is your fp, fp is positive. यहाँ positive से negative जाना है. This is your p and this is your q. You will have to cross it once, or what you can do is you can cross it this 3 times or 5 times or 7 times. So there will be an odd number of roots between p and q. But if fp into fq is greater than 0, this is your fp and this is your fq, p and q. We have to come from here to here. What will happen? Once we go down, and either we come up like this. So 2 roots. Or we can do this. This is your p and this is your q. You don't intersect it at all. In general, we are saying, not just for quadratic. Or we may have 4. This is your p, fp and fq. So this says it will have either no real root or even number of roots between p and q. Important result which we use in questions. Then number 3, if fp is equal to fq, that means how are you going to draw this? This is your FP and this is your FQ. From here you are going, say down, you have to come back to this point. So if you go down, or you might go up, or you might go, I think you've done Rolle's theorem in 10th. This you will do. If you have not done, you will do Rolle's theorem that if FP is FQ, then F dash X, वो dash लिखा हुआ है, the derivative will be 0 at least once between P and Q. Between P and Q, because this is how the curve is going to be. If it is like this, derivative is 0 का क्या मतलब है? The tangent at some point is parallel to the x-axis. That means slope of the tangent is 0. This all for continuous functions. Polynomials, they are continuous functions. When you will do Rolle's theorem, fx will be any function. We'll impose the condition that it is a continuous function. So this is not exactly Rolle's theorem, but it is Rolle's theorem as applied to polynomials. So if you have fp is fq, then f dash x equal to 0 has at least one real root between p and q. Now, the next is a very important result. It's called, just slide it a bit more. Yes. What it says, number 4, if the coefficients of a polynomial has p changes of sign, then fx equal to 0 will have at most p positive roots. Right? So let us see, let me take some equation. 2x to the power 5 minus 4x 4 plus x cube plus x square minus x plus 5 equal to 0. Suppose this is my polynomial. I will just write down the signs of the coefficients. The first coefficient is positive, then negative, then positive, then positive, then negative, then positive. How many changes in sign? This is 1, this is 1, this is no change in sign, this is 1, this is 1. There are 4 changes in sign in the coefficients. So what it says, it can have at most 4 positive roots. Is that clear? This is what this result says, that this polynomial can have at most, ज़्यादा से ज़्यादा, at most word is very important. Exactly नहीं है. It may not have any positive root. It may have all positive roots. 4, but it can't have all positive. 5 नहीं हो सकते. Right? And the next result says, if the coefficients of the polynomial, f of minus x क्या होगा? ये हमारा fx है. Change x to minus x. So it will be 2x to the power 5, negative sign आ जाएगा. Right? Plus आएगा, same रहेगा. Minus. X को minus x किया ना, even powers में change नहीं होगा. In odd powers, the sign will change. Minus x cube plus x square plus x plus 5. What are the signs? Minus, 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 plus, plus, plus. How many changes in sign? 1. So it can have at most 1 negative root. At most 4 positive roots, at most 1 negative root. And the next, so it says that it can have at most p plus q real roots, where p and q are the change of signs of ये 4th और 5th को combine करके का. And this is called a very important result. बहुत simple सा है. Descartes' rule of signs. What is it telling you? It is just telling you how many positive and how many negative roots it can have at most, if at all. And sometimes this condition, we are happy with this. हमें सिर्फ इतना ही चाहिए होता है. Is that okay? Is this clear? Let me take up another example and you will tell me. I have this. How many positive roots can it have? वैसे भी देख सकते हो ना, कोई पॉजिटिव इसका रूट होगा, एवरीथिंग इज पॉजिटिव, वैसे भी बता सकते हो, है ना. एवरीथिंग इज पॉजिटिव तो जीरो कैसे आएगा? नहीं आएगा, है ना. अदरवाइज चेंज इन साइन से पॉजिटिव पॉजिटिव सारे लिखने की भी जरूरत नहीं है, बस सिर्फ साइन देख लो, कहीं चेंज नहीं हो रहा. सो इट कैन नॉट हैव एनी पॉजिटिव रूट. इंफॉर्मेशन हमें बहुत अच्छी है. नेगेटिव रूट एफ ऑफ माइनस एक्स का देखना है. तो एफ ऑफ माइनस एक्स क्या है? जस्ट सी हाउ मेनी चेंजेस ऑफ साइन. ये आ जाएगा माइनस एक्स टू द पावर 7. आफ्टर सम टाइम तुम ये लिखोगे ही नहीं, वैसे ही बोल दोगे. 1 2 3 4 5 6 7. So it can have at most 7 negative roots. Real. Maybe it doesn't have any real roots. But if it has, it cannot have any positive root, and at most it can have 7 negative roots. Right? So this result is very useful. एक ये इक्वेशन देखते हैं. एक्स क्यूब माइनस 1, ये तो बहुत अच्छे से आती होगी. इसका कितने पॉजिटिव रूट्स हो सकते हैं? 1 चेंज ऑफ साइन है, 1 पॉजिटिव रूट एट मोस्ट एंड no negative roots. Otherwise, do you know what are the roots of this equation? This is what? Cube root of unity. तो इसके roots क्या है? Cube root of unity तो 10th में अच्छे से पढ़ा होगा. क्या है roots इसके? x equal to 1. बस. तो कितने roots होने चाहिए? Every equation of degree n has exactly n roots. Every equation. So बाकी roots कहाँ गए? एक ही आया ना. Yes? Anybody? Yes. So what do we get? What are the factors? X minus 1 into x square plus x plus 1 equal to 0. So 1 is x equal to 1. Don't forget this one. So x is 1 or what? Find the roots. निकालो. ये तो वैसे ही याद होना चाहिए. What are the roots? रूट -3 कैसे लिखते हैं? I रूट 3. ठीक है या नहीं? बाय 2. ये हो गया -1 प्लस I रूट 3 बाय 2 एंड -1 माइनस I रूट 3 बाय 2. इनको कुछ नाम देते हैं. अगर ये कॉम्प्लेक्स रूट्स तो हैं. दिस इज द टाइप. ये ओमेगा है तो ये क्या होगा? ओमेगा स्क्वायर. एग्जैक्टली. This is what I was trying. So what are the roots of the cube roots of unity? 1 omega omega square, where omega is -1 plus I root 3 by 2. इसको नहीं omega कह सकते. If I say let omega be -1 minus I root 3 by 2, इसको मैंने ओमेगा कहा. तो फिर ओमेगा स्क्वायर क्या होगा? इसका स्क्वायर क्या हो जाएगा? यही आएगा ना, ओमेगा आ जाएगा. If this is your omega, its square will be omega to the power 4 and omega cube is 1. तो ये आ जाएगा. You can calculate. With omega cube equal to 1. ये बहुत यूज किया होगा. So you should know what are the cube roots of unity. 1 omega, omega square with omega cube as 1, where omega you can take any one of these two. Either you can take this or you can take this. Generally यही लेते हैं. -1 plus I root 3 by 2. Is that okay? So ये भी in your formula you should know this. Now just as you have quadratic equations, if you have a cubic equation, ax cube plus bx square plus cx plus d equal to 0, you can write the relation between roots and coefficients. You can write the relation between roots and coefficients. If the roots, how many roots will it have? 3 roots, alpha, beta, gamma, and what we have is sum of the roots, sum SUM, SUM meaning is equal to minus b by a. Sum of the product of the roots taken 2 at a time, alpha beta plus beta gamma plus gamma alpha, is c by a. And product of the roots is equal to minus d by a. If you just observe that first you have a negative sign, then positive, then negative, and so on. और इसको हम simple way में लिखते हैं. इसको हम what we do is इन दोनों terms में से alpha common ले लेते हैं. We write it as alpha into beta plus gamma plus beta gamma. There are other ways also of writing it. You can take beta common. So beta into alpha plus gamma. Basically this is one root into sum of the other two plus जिनका यहाँ पे sum लिया था उनका product लेना. You have 3 numbers, you are going to take 2 at a time. If you have, this is extended, if you have an equation of 4th degree, this again, you have the sum of the roots. This is minus b by a. Sum of the product of the roots taken 2 at a time. कितने आएंगे? 6 combination आएंगे. तो उसको हम ऐसे factorize कर सकते हैं. सारी terms लिखोगे. This is a simpler way to write it. Alpha plus beta, sum of 2 roots into product of the other 2. Plus जिनका यहाँ sum लिया उनका product, जिनका यहाँ sum लिया उनका product is c by a. Then alpha beta 3 लेने हैं एक बार में, plus gamma delta into alpha plus beta is minus d by a. Then product of all the roots is e by a. Minus plus minus plus. This result can be extended, but here in your syllabi we are concentrating mostly on quadratic functions, quadratic expression and quadratic equations. A lot of these results we are generalized to these also. Okay. Okay, thank you. Thanks a lot for your patience. I appreciate that you have this much of stamina, but you really need it for your IIT preparation. You should be able to sit for at least 3-4 solid hours without moving. And this is the practice you are getting. Thank you.
although he was laying emphasis on an atom. Classical mechanics is something which talks about macroscopic objects, and quantum is something which talks about microscopic objects. All right, and when we talk about classical, this is basically based on Newton's laws of motion, and quantum is based on Planck's theory. Okay, so now when we talk about the classical, here when we say that this is based upon class macro, this is micro, there is a branch of science which interacts, which talks about the two. Say if you want to know about something, if you want to know about a macroscopic object from microscopic point of view, then there is another branch of science, and that is known as statistical. You should just know about it. Okay, that is it. We will be doing Pauli's exclusion principle and Hund's rule and etc. the other rules towards the end. But here I want to lay emphasis on that these are the by and large mechanics which hold your atomic structure together and which helps you to study the atomic structure in detail. So you have quantum study of micro, classical study of macro, and statistical, which helps you study the macroscopic objects from microscopic point of view. Okay, then why do we study quantum? जब डाल्टन ने एटॉमिक थ्योरी दे दी थी, then what was the need to study quantum mechanics in detail? The problem was that there were certain failures in classical mechanics which could not be accounted for by the study of macroscopic or just the Newtonian laws. What were those failures? Some of which are there in your course and some are not. You have the black body radiation. So you should know what is a black body radiation. It is an object which absorbs and emits all kinds of radiations, right? Then next we have the Planck's theory. Planck's theory. Now let me just tell you, in 1900, Planck hypothesized that there is something which is called as a quanta. He stated that, say, if I have different energy levels, just consider this. I have some energy levels just as you climb up the stairs. So I have certain energy levels. He stated that if an electron has to jump from one level to another level, there has to be some minimum energy required for it, a quantum or a discrete bundle or a packet of energy which is required for it to jump from here to here. He gave this concept in 1900, but it was taken with a lot of controversies. Scientists were not willing to accept that there is something which is just existing in discrete bundle. It was like if one of you is standing here and you have to jump to the other side. How will you go? You will simply walk down. So this is like a continuous form of energy. You understand that? If I make you stand here and I ask you to go till the wall, you will simply walk through. This is your classical mechanics. Classical means your energy is in a continuous form. All right. But if I suddenly dig a deep pit here, and then I ask you to reach to the other side, can you reach unless and until you have that much amount of energy to jump to the other side? And say supposedly just after that particular region you have another pit. So if you have more energy, then also it doesn't help. If you have lesser energy, then also it doesn't help. But if you have exactly that much amount of energy, which is a quanta, then you can easily jump from this side to that side. Clear to everyone? So this is what is all about. When we talk about classical, we are talking about energy in a continuous form. So if I talk about, if this was classical, your energy would have been simply continuous. Why? In classical, the energy levels are closely placed. In classical, your energy, these energy levels are very closely spaced. So if at all your transfer of energy has to happen, it will simply happen in a continuous fashion. Whereas in quantum, you have discrete energy levels such that you need a particular bundle to jump from one place to another. Clear? So this is like one Planck's theory. And then you have the photoelectric effect that we'll do in detail. Then we have Compton effect and heat capacity of solids. Compton effect refers to the change in wavelength of the X-rays. When X-rays, you've done photoelectric effect once. Photoelectric effect, I will revise for those of you who have missed. Photoelectric effect is the ejection of electrons when a light of a certain frequency falls onto your metal surface. Right? Here in case of Compton effect, it is the change in the wavelength when X-ray is impinged onto a substance. The wavelength would be changed. Basically, it refers to the change in wavelength. This change in wavelength could not be explained by classical mechanics. And then heat capacity of solids. You know what is heat capacity? I will just tell you from the top that for the heat capacities, actually according to one of the laws, molar heat capacity for solids is a constant. But at higher temperatures, it doesn't turn out to be a constant. So that deviation could not be significance to it. So what I'll do is I'll take my wave function, multiply it by its complex conjugate. Okay, I will multiply it with its complex conjugate to make it real. Now can I attach any significance to it? Yes. Now just see that this is describing your electron. This is known as probability amplitude. Just note down the terminologies. That is all that is required. This is known as the probability amplitude. And when you multiply it with its complex conjugate, this is known as the probability density. Psi is the probability amplitude. Psi star is the probability density. And this is what tells you about the maximum probability of finding an electron in a particular region of space. It is the probability amplitude. Generally, it is defining your, as of now, you can just understand that it is defining your electronic system, any electron. Each one has a different wave function. Now here, wave function when, so that means I don't know psi, there is no physical significance of psi, but when it is multiplied by its complex conjugate, this is, it makes it real, and your psi, as I stated, is your probability amplitude. And what else did I say? There is no physical significance. Why, if anyone asks you? Because it can be real or imaginary. So I'm not sure whether it is real or imaginary. Next, if I multiply it with its complex conjugate, I get the probability density. And when I talk about probability density is nothing but, just note down, it tells you about the maximum probability of finding the electron in a particular region of space. Okay. Now here, just look up onto the board again. Psi, no significance. Psi star, it is real. So definitely it has a significance and it gives us the probability of finding the electron. So that means now I'm talking about the electron clouds. Now I'm talking about electron clouds. It definitely has a physical significance. Now, this I told you is an energy operator. Whatever property we talk of macroscopic objects, like we all possess kinetic energy, we all possess potential energy, right? In a similar fashion, our systems, I mean, when we talk about quantum mechanical systems also, they have similar energies possessed by them, right? So here in this case, this energy operator means it may be some kinetic energy operator plus the potential energy operator. Operator is generally denoted by this cap on the top, into psi is equal to E psi, right? And I tell you, Schrodinger wave equation, remember, has no definition, no derivation as such. No derivation because it is a postulate. Postulate is something that I state that there is this duster is erect. I've just stated without any proof. Okay. Now you will come and you will prove that yes, she was correct. So what I've just guessed, made a guess, not a guesswork, but what I've actually logically arrived at is nothing but a postulate because I have given my statement straight away without arriving at it. But somebody else may try to look at it from a different way and apply different theories to it, and you will find out that yes, what I was saying was correct. So the meaning of postulate is something which has been given based on logical deductions as such, but with no derivation. So remember that there is no derivation of Schrodinger wave equation. Second thing that you can note here is Schrodinger wave equation can be solved exactly only for hydrogen atom and similar systems. So this can be solved only for hydrogen atom and similar system means He plus, Li2 plus, Be3 plus and so on. Okay, the only real system that can be completely solved is hydrogen atom. Then coming back to what I was stating initially, that if I'm talking about the operators, if I'm saying that if macroscopic objects possess a kinetic energy, microscopic will have a corresponding quantum mechanical operator for them. So here in this case, let me tell you the linear momentum operator, this is only for your knowledge sake, is h upon 2 pi I d by dx. This is your linear momentum operator. This was again postulated. From here, we arrive at the kinetic energy operator. What is kinetic energy? P square by 2m. That turns out to be equal to minus h square upon 8 pi square m, then d square by dx square, right? And if I'm talking about, say, the kinetic energy in all the three dimensions, hydrogen atom is a real system. So it will exist in all the three spatial dimensions. So what will that be? This is the kinetic energy operator along x direction. So I will have a kinetic energy operator along the y direction also. H square upon 8 pi square m d square by dy square minus h square upon 8 pi square m d square by dz square. All right, this entirely is my kinetic energy operator for the electron. All right, this is for the electron. All right, kinetic energy. Now for the potential energy, what is my potential energy? Let me denote my potential energy, say, with a V. V operator, just coming to the equation that is mentioned on the screen, into psi is equal to E psi, right? I can take h square by 8 pi square m common outside. What will that be equal to? That will be now d square by dx square plus, sorry, yeah, okay, plus d square by dy square plus d square by del z square, the whole into psi, and then you take your minus, multiply this equation with 8 pi square m upon h square. If you multiply this equation, the entire both LHS and RHS, with 8 pi square m upon h square, what will you get? Plus 8 pi square m upon h square, all right, into E minus V. I'm just rearranging, all right, getting my E on this side and multiplying it by the minuses. If you carefully look at it, you can easily get it is equal to 0. This is what is given. Now you write this as the Schrodinger wave equation. Absolutely correct. You write this, this, or this as the Schrodinger wave equation. It is absolutely correct. All you have to remember is, what is the kinetic energy operator? Minus h square upon 8 pi square m d square by dx square. Clear? I repeat it again. We have the kinetic energy operator here. What is your kinetic energy operator? Minus h square upon 8 pi square m d square by dx square. And if you remember this, then for the y direction and the z direction, it is just the same, right? Kinetic energy operator plus the potential energy operator, the whole into psi will be equal to your E psi. And then you rearrange and get it in whatever form. So never get boggled up by looking at the Schrodinger wave equation, that it is very difficult. I am repeating the Schrodinger wave equation once again. One thing, what is wave function? It is the identity of an electron. Psi is known as the probability amplitude. There is no physical significance of psi. Why? Because it can be real or imaginary. Okay, it can be real or imaginary. Then how do you make it important? If it is imaginary, what is the point of studying? We will multiply it with its complex conjugate. When we multiply it by its complex conjugate, psi star will give me the, it will give me the probability density. What is probability density? Say if I am getting the probability density, I will get a picture as to where exactly or what is the probability of finding the electron in a particular region of space. Okay, then what is the next thing? Then I can come back to my Schrodinger wave equation. What is Schrodinger wave equation? H operator psi is equal to E psi. You know how wave function can always come back when your energy operator is applied. That wave function along with the value will give you the value of energy. Because this is energy operator, so I will get the value of energy only because this belongs to this operator. Now the total energy can be generally termed as kinetic energy operator plus potential energy operator. What is kinetic energy? It is minus here. Normally for your macroscopic systems, you say that the kinetic energy is equal to half mv square. Now here in this case, your kinetic energy is minus h square upon 8 pi square m d square upon dx square. Have you done partial derivatives? No. D square by dx square. Otherwise, there is an uncertainty attached to everything when you talk about microscopic entity because you are never sure as to where it is. If you locate the position, there is an uncertainty in the momentum. This you have done in a rule also, which we'll just quickly recapitulate. Clear? You can write it down now. You have the kinetic energy operator as minus h square upon 8 pi square m d square by dx square, repeated for the y direction, repeated for the z direction, plus the potential energy operator, the entire multiplied by the wave function is equal to simple E psi. Then you rearrange in the way you want to get the equation which is given in the question, if at all, if it comes. Okay, this is the only thing which is there in your course from the Schrodinger wave equation point of view. Next, I tell you, we solve this. You know that there are solutions of differential equations. We are not solving these equations, but let me tell you that on solving these equations, there are two things that we are interested in. One is we are interested in the energy, and the other is the wave function. For the wave function, here I get the answer in terms of two more wave functions. One is a radial wave function. Okay, this is also a wave function. I'm not drawing it like this, but then a capital R means radial wave function into an angular wave function. Can you get it? Radial wave function is dependent upon the radial part, and this is dependent upon two angles theta and phi. All you need to remember is that. I repeat, whenever we write down, we are writing down the Schrodinger wave equation in the differential form. Because Schrodinger actually did his quantum mechanics using differential equations only. And now you know H operator psi is equal to E psi is your basic Schrodinger wave equation. And when you elaborate that, you can put in the kinetic energy operator and the potential energy operator, and then you can write it down in the elaborative form that as is written on the board, on the screen slide there. So the wave function is equal to radial wave function into A. Now just keep looking at it. If I plot my radial part, radial wave function with say R, then this is my probability amplitude. For the 1s orbital, you have different orbitals, right? For the 1s orbital, it turns out to be something like this, right? For the 1s, it turns out to be something like this. Now just carefully look at it. Can I give any significance from this? This is only R. So R is just a wave function. It is not multiplied by its complex conjugate. So that means I cannot attach any physical significance to it. Just remember that. If it is simple wave function, it can be real or imaginary. So I cannot attach any physical significance to it. So what do I have to do? I should be taking at least R square, R into R star, right? And that, when plotted, gives us something like this. Again, because it will only be with a higher, when you square it, it would look similar only. Now here, what is now I can give an interpretation from this graph. So you have to make sure that you note down the x and the y axis label also properly. If it significance to it. If it is the square of the wave function, yes, now you can tell about the probability density. And what is that? It is telling you that there is a maximum probability of finding the electron when R is equal to 0, which is not correct. Why? Because do you find the electron embedded in the nucleus? No, it is revolving around the nucleus at a particular region. right? So why is that a problem? Let me tell you that these kind of curves are known as probability density curves. These are known as the probability density curves. And for 2s, only for 2s, you can just note down, it looks something like this. So when you square it, this is for r for 2s, and when you square it, it looks something like this. All right. Again, the maximum probability using the probability density curves is that you are getting a maximum probability of finding the electron in a region where r is approaching almost 0. So we are not getting the correct information despite solving the Schrodinger wave equation completely. So what do we do? The answer is that you have your nucleus here, right? Your electron is not revolving in a specific orbit as was stated by Bohr. It is some volume element. It's a spherical shell because your electron can't revolve around the nucleus in a particular region of space because it's like a microscopic entity. It cannot just remain at one particular point. It will keep on moving, right? So here, that means I need to include this volume element of the spherical shell also. Okay. Now, what is the volume element? You have the nucleus here. What is the volume element here? The volume element is you have the volume of the outer sphere minus the volume of the inner sphere. That is what is where your electron is contained. Though, say if this is R and this small area is dr. Okay. So now here, what will be your volume? It will be 4 by 3 pi r plus dr whole cube. Minus 4 by 3 pi r cube. R cube, because you have only, the inner sphere is only r. The outer one is r plus dr. So now earlier we had not taken anything into consideration. We just took the solution as it is. The expression for this need not be remembered. You can just remember that the probability density curves gives you a picture that the maximum probability of finding the electron is at a region where r is approaching 0. That is incorrect because we are not taking the volume element into consideration. How do we take that volume element into consideration? That is the outer sphere minus the inner sphere will give you the volume of the spherical shell. And when you open it up, 4 by 3 pi r cube will get cancelled. You will be left with 4 by 3 pi dr cube also. Now dr is already very, very small. So dr cube will be even more small. So you can easily ignore the dr cube also. So the only term that you will be left with will be 4 pi r square. We'll not ignore the simple dr term. When you ignore the rest of the terms, I am coming directly to the expression. The volume element that comes out to be is equal to 4 pi r square dr. Clear to everyone? Now, when I put this in along with r square, then I get the curve for my 1s as, this is for my 1s. I will label here 4 pi r square, capital R square, which is my wave function, into dr, this versus r. So now this is giving me the correct picture that there is a maximum probability of finding the electron at some region from the nucleus. Okay, these curves are known as radial density distribution curves. So which of the two are better? Radial density distribution curves. What is the significance of radial density distribution curves over the probability density curves? You are including the volume element. Okay. Clear? You are doing Schrodinger wave equation for the first time. I repeat it once again so that it sits in your mind throughout. Each electron will be known by its wave function. That wave function has no physical significance. Why? Because it can be real or imaginary, right? Now, so how do you attach physical significance to it? By multiplying it with complex conjugate. So psi star will give you the probability density, from where you can give the maximum probability of finding the electron in a particular region of space, right? Now, when I talk about the Schrodinger wave equation, what is that? H operator psi is equal to E psi. All of you all remember that? What is Hamiltonian operator? It is the energy operator. What is energy? Kinetic energy plus potential energy. What is your kinetic energy? Minus h square upon 8 pi square m d square by dx square. For y and z, you can write it down. Plus potential energy is simple, V, right? When you write down the plus potential energy whole, gives you the Hamiltonian operator, into psi is equal to E psi. Simple Schrodinger wave equation written. It can be solved completely for hydrogen atom. We get some solution of the type, some radial wave function multiplied by some angular wave function. When I plot my radial wave function square, that is probability density only. So this is probability density curve. It gives me an information that there is a maximum probability of finding the electron at a region where R is approaching 0, which is incorrect. Why? Because I'm not taking the volume element into account. Because my electron, if this is my nucleus, electron is revolving around the nucleus in a particular spherical shell. So I need to include the volume of this spherical shell. And how do I include that? By taking the volume of the spheres. What is the volume of the outer sphere? If this region is dr and this is r, so volume of the outer sphere will be 4 by 3 pi r plus dr whole cube minus 4 by 3 pi r cube. All right, when I open the expressions a plus b whole cube, you know, I will get dr square and dr cube terms, which I will ignore. Ignore why? Because dr is already very small, so the square and the cube terms would be even more higher. So then I will finally get 4 pi r square dr. You can remember this term? Now you know. You don't need to remember all this. All you need to remember is that we had included some volume term along with my radial density, along with my radial probability density to give me the radial density distribution curve, which comes out and gives me the correct picture. And for the hydrogen atom 1s, this maximum distance turns out to be equal to, this is for the hydrogen atom. And if I have to draw the radial density distribution curve for at least 2s, you can remember from your entrance examination point of view, it will look something like this. This will be 4 pi r square, r for 2s now, dr, 4 pi r square dr is your volume term, r. So that means there is some probability. So can you see that even in the 1s region where you were getting a curve, a sharp curve, intense peak here, I mean intense and broad peak here. Now here you are again getting, so that means for a microscopic entity, it is all a probability. It can be found because it is like constantly moving. So you cannot ignore the probability of it being found at other places as such. And so that is why we talk about the spherical shells. Clear with this? So this is basically the final quantum model that was proposed by Heisenberg, and this is what we work on. In a similar fashion, let me tell you, Heisenberg also did a study, but you were doing matrices and determinants also? You will be doing it. Heisenberg had done his study with matrices only. Matrices and determinants look something like this. 1, 1, 1, 2, 3, 4, something like this, right? So Heisenberg had done a similar study. Both of them were doing it in separate countries, independent research. Final results for the atomic model turned out to be the same. But because Schrodinger's wave equation is easily understandable, so we can comprehend it, and so that is why we are studying Schrodinger wave equation here. Next, we move on to the Heisenberg's on some rules of quantum mechanics, which are very important. The total number of nodes were given in the previous case. The total number of radial nodes, you can note down the formula, that is n minus L minus 1. The total number of nodes is equal to n minus L minus 1, and angular nodes is equal to L. Right? So you can quickly find the number of radial and angular nodes in a 5p orbital. You know that when we talk about S, P, D and F, these are the various shells that we will now talk about. So for this, L value is 0, 1, 2 and 3. And you already know that your what are the quantum numbers that we get from Schrodinger wave equation? We are solving the Schrodinger wave equation. We completely talked about it. We arrived at a wave function value, right? That wave function value was R into A. Another thing that we can arrive at is the energy. Please make a note that this energy is similar to the Bohr's energy that we calculated. 2 pi square m e to the power 4 z square k square upon n square h square. Please check it that the energy is just the same. So the energy obtained here in case of hydrogen atom is exactly the same as obtained from the Bohr's model. Clear? So what we were interested in, wave function done, energy done. Apart from it, we get some quantum numbers. What are these quantum numbers? These are the ones which actually quantize your concept. Say if I'm telling you that the energy is say some 5 units, the next one will be 10 units, the next will be 15 units, the next, so the quantum number will be 1, 2, 3 and so on. Right? So the quantum numbers that I arrive from the Schrodinger wave equation are N, L and M. On solving the Schrodinger wave equation, we get only 3 quantum numbers. N, which is the principal quantum number, L is the azimuthal or the subsidiary or the secondary quantum number. All 3 names belong to L only, right? And M is the magnetic quantum number, right? We get only 3 quantum numbers by solving the Schrodinger wave equation. Is that clear? Because the model was given by Schrodinger, so you should know that we could get only 3 quantum numbers from there. The fourth one, that is the spin quantum number, was discovered. It was a chance discovery by Stern and Gerlach, who talked about the spin of the electron to be either clockwise or anti-clockwise. When it is clockwise, it is either denoted as plus half, and when it is anti-clockwise, it is minus half. It is also upspin generally is plus half and downspin is generally minus half. So remember that on solving Schrodinger wave equation, we could get only 3 quantum numbers, N, L and M. And the fourth quantum number, N, was obtained by Stern and Gerlach, which was given after their experiment and it was added on to them. And then different rules were given. Okay, the next question can also be solved here. How many nodal planes are there in 2px, 3px? The nodal planes is generally equal to the angular nodes. What is angular nodes equal to? L. So what is L here in this case? 1. So therefore the nodal plane here in this case will be 1. Because you don't do nodal plane word otherwise, so that is why I put this question. Whatever twists you can get, I've tried to put maximum of them here. And radial and angular node is already done. Radial was 3 and angular was 1. Change. Okay, so now what we are getting is now N, L and M. You know about these. I don't think I need to throw a lot of light on it. Just quickly go through. Principal quantum number represents the distance between the electron and nucleus, and it also gives you the energy because it is nothing but n square, and then energy is directly proportional to n square here in this case. Then you have azimuthal or the secondary or the subsidiary quantum numbers, one and the same thing. So remember that this is one quantum number. It represents the number of the subshells that you have, and you know that the values can be given from 0 to n minus 1. And it gives the shape of the subshell. S, if it gives the shape of the subshell, S is spherically symmetrical. Now it is not a postulate. You solve the quantum mechanics. The angular equation has a particular expression. We plot it and then we get the shape. You can just understand it from the top that we are solving the Schrodinger wave equation, which is not in there in your course. We solve it, we get an expression, then we plot it. You know how to plot a graph? So then we plot it and then we see that it is turning out to be spherically symmetrical for S, dumbbell for P, double dumbbell for D and complicated for F. Then you have the magnetic quantum number, which is given the values from minus L to plus L. It goes through 0, right? And M is equal to 2L plus 1. For any value of L, it also explains the orientation. Next, we have spin quantum number. Do we obtain the spin quantum number from Schrodinger wave equation? Remember. Okay. When an electron rotates around a nucleus, it spins either clockwise or anti-clockwise. So that is what defines your spin quantum number. Then these questions, I think we need to do some rules before doing these questions. Turn. Change, please. So here we need to do some rules. One of the rules is what you have focused on and done a lot of numericals based on it. Heisenberg's uncertainty principle. What is Heisenberg's uncertainty principle? That you cannot determine the position and the momentum simultaneously. Please note down the other form of the Heisenberg's uncertainty principle also, which is there in your entrance examinations always. You also cannot predict the energy and the time for which the microscopic entity is staying in a particular orbit or a particular level. Delta x into delta p, you all remember, it is greater than or equal to h upon 4 pi. Another one also, please remember, this is the other form of the Heisenberg's uncertainty principle, that delta E into delta t is greater than or equal to h upon 4 pi. So just by looking at the expression, you define your Heisenberg's uncertainty principle, that it is not possible to determine the position and the linear momentum simultaneously for a microscopic entity. So how will you define the other one, the other expression? It is not possible to determine the energy and the time for which the electron is staying in a particular level simultaneously and exactly. Okay. Next is the Aufbau's principle. Aufbau's principle, it states that an electron enters the orbital that has minimum energy or the one having lower energy first, right? And this is, do you know how to make this table? The ones who are sitting here? Otherwise, it is a simple one that you can simply construct. You have 1s, 2s, 3s, 4s, 5s. Just a quick recapitulation. I know you all know. This is 2p, 3p, 4p, 5p, and then you can put 6p if you want. We do not generally, at this level, you will not go beyond a particular level. So then you have here 3d, 4d, 5d. All right, I put 6p. All right, and then you have, here you have 4f. So you all know. What you generally do is, you just put slanting lines like this, right? And based on this, we'll quickly do the electronic configurations. You've covered up the electronic configurations? So you can quickly do the electronic, then I pick up atoms and then give them to you. For after 1s, what will get filled? 2s. After 2s, you have 2p. After 3s, you have 3p. After 4s, you have 3d, and then you have 4p and so on. Right? Here there are two rules. One is the Aufbau's principle. There is another rule which is known as the n plus L rule. That whichever orbital will have a lower value of n plus L, that will get filled first. Now here, I mean, if you compare 4s and 3d, so what will it be? 4 plus 0, because S has an L value of 0. And what about 3D? It is 3 plus D is 0, 1, 2. So S for 0 and P has 1. D has 2. So that means this has a value of 5 and this has a value of 4. So which gets filled first? 4S gets filled first. All right, this is your N plus L rule. Now, if I give you the electronic configurations, do it for phosphorus. All right, scandium, chromium, do it for copper, and do it for zinc. Do you remember the 21 to 30 atoms? Skr, Ti, Ver, Kr, Man. You can remember it like that. For those of you who do not remember, just do it now. You have Skr, Ti, Ver, Kr, Man, and just repeat it. This is how I used to do it. So just repeat it at least 5-6 times. Skr, tai, Kraman. Just repeat it here. Skr, tai, Kraman. And fi, ko, ni, ku, zn. Simple. 5 first. This is like atomic numbers 21, 22, 23. Then you have 24, 25, 26, 27, 28, 29, and 30. Right? For all those of you I have given you a question here, write down the electronic configurations according to the Aufbau's principle. You will be filling up the electronic levels. And for those of you who do not remember 21 to 30, it is very important that you remember at least the first 30 atoms according to their atomic numbers. 20 you did it till 10th. Now it is important that you do 21 to 13. How will you do it? Skr, tai, kraman. Alright? Repeat it. Skr, tai, kraman. Fi, ko, ni, ku, zn. Do it again. Fi, ko, ni, ku, zn. So next time when somebody tries to irritate you, just say fi, ko, ni, ku, zn. He will not understand what you said. Right? You can do that. It's a good way of memorizing things, because I tell you there is a lot of effort that needs to be put from your side. So constantly you should be into your sciences rather than paying attention to any other thing. Okay. So what is it? Skr, tai, kraman, fi, ko, ni, ku, zn. So first 5. Skr, tai, kraman, fi, ko, ni, ku, zn. Okay. Keep repeating it at least 4-5 times. Memorize it right here, right now. We have ample time and you can remember that. And let me tell you the names. I'm teaching you chemistry. I'm not teaching you music here. It is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Very intelligent. Phosphorus, what is the atomic number? 15. Very good. I hope you all remember the first 20 atoms. If anyone has any problems, can contact me. So for phosphorus, how will we start? I hope you remember S can get a maximum of 2 electrons, P can get a maximum of 6 electrons, D can get a maximum of 10 electrons, and F can get a maximum of 14 electrons. Right. So if we start beginning with the electronic configuration of phosphorus, it will be 1s2, 2s2, 2p6, 3s2, 3p3. Okay. And there is something which is known as the stability of fully filled and half filled orbitals that you would be doing in the periodic properties. If you remember, S is like shown like this. If this is 3s, this is your 3p, then this would be 3s2 and it would be 3p3. We will just be doing a rule. Which rule is this? Hund's rule of maximum multiplicity. That pairing will not begin unless and until each orbital is singly filled first. Okay. Next we move on to scandium. Now what is scandium? 21. Now there should be no error. Scandium is 21. So what is that? 1s2, 2s2, 2p6. Till 2p6, 10 get over. 10 electrons are taken care of. Then you have 3s2, 3p6, 4s2. Why? Because 3s, then you have 3p, then you have 4s. After 4s, now it is the turn of 3d. So that will be 1. And just as you had the knowledge before, it has only one electron, so it can be easily given from this particular shell. But one thing that I will just tell you is, whenever you will talk about scandium plus, the electron will be lost first from 4s and not from 3d. So you can have the most stable configuration for scandium as plus 3. You take out 2 from here and then 1 from here. Because finally you should be writing down the configuration as, you know that filling will be done according to the Aufbau's principle like this, right? This is your Aufbau's principle. Now here, when you are finally writing down the electronic configuration for your theory examinations, it should be given as 3d1 4s2. This is the correct way of giving it. Okay? Then for chromium, what is chromium? Do it for manganese also, because that is 25. So this is 24. Change. Now what will it be for chromium? The first remains the same only. So what you have 1s2, 2s2, 2p6, 3s2, 3p6, 3p6, and then you have 4s. For the timing, for those who have not attended it before, after 3p we are filling 4s. 4s can accommodate a maximum of 2 electrons. So 4s 2, let me just, because the ones who are beginners will not know then, and it will be 3d4. But this is not the correct electronic configuration. Why? Because half-filled atomic orbitals are more stable than the others. So here in this case, D can accommodate a maximum of 10 electrons. So if I make it 5, then in that case, it will be half-filled. But where does it take that 1 electron from? So it will take 1 electron from here, add 1 here, and this is what it becomes. So the final configuration of chromium will be written as, 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. So if I ask you the electronic configuration for chromium plus, what will that be? Chromium plus will be simple. The outermost will be 3d5. I mean, of course, the rest of it remains as such. So this is 3d5 then. Now, the next was manganese. Now, manganese will be simply same till that place. 1s2, 2s2, 2p6, 3s2, 3p6, 4s, 4s2, 3d5. So this will be 3d5, 4s2. Then the next was copper. Copper is, now how do you say that? Skirt I Vakraman, 25 gone, 26, 27, 28, 29, 30 is Fico Niku Zn. Right? So Fico Niku is 29. So 29 means now I'll fill 29. 1s2, 2s2, 2p6. 10 electrons taken care of. 3s2, 3p6, 4s2. 4s2, I mean for the beginners. 4s2, for those of you who've missed, I've got to know some of you have not come before. So 3s2, 3p6, 4s2. So another 10 taken care of. So that means we are done with 20. And then you have 3d9. Okay. Then 3d9 again, fully filled and half filled orbitals are more stable. So here D can accommodate a maximum of 10 electrons. So where will it get the 10th electron from? The 4s orbital. So it takes 1 from here and it becomes 3d10, right? So this is how it becomes. So now try the zinc quickly. For the zinc, now what do you have? It's 30. Zinc is 30. So that is 1s2, 2s2, 2p6. First 10 electrons taken care of. Then 3s2, 3p6, 4s2, another 10 taken care of. So 20 till here. If you remember, you will never go wrong in filling up the energy levels. Then you have 3d. I'll just write it here itself. 3d10. Okay. So you say that zinc is a fully filled. No, it's not noble. It's actually a transition metal with a fully filled d orbital outside. So generally they are not considered to be a d. They are there in the d block. Have you seen the periodic table carefully? Then in the end you find zinc, cadmium, mercury. Zinc, cadmium, mercury, all of them, zinc, cadmium and mercury, all three of them have a 3d10 configuration. 3d10, 4d10, 5d10. They have a d10 outermost configuration. So they are fully filled. So generally the fully filled ones are like quite apprehensive to give an electron or take an electron because fully filled orbitals are as such stable. So that is why they are not considered to be directly showing properties as similar to other transition metals. You remember S are alkali and alkaline. Then you have the p block elements which has the non-metals in it and the noble gases. Then you have the d block elements which are the transition elements, and in the transition elements you have Skirtai, Verkraman, Fico, Nico, Zn. All this 21 to 30 are in your d block. Because why? Your d block has started getting filled from here. D1, D2, D3, D4, right? So scandium to zinc, it is all D block. It is the first row. And because it is 3D which is getting filled up, it is called a 3D transition series. It is called a 3D transition series. I mean, this one, the entire score to scandium to zinc. Clear? Next slide. And here you have the Hund's rule. You can just quickly go through what is Hund's rule. You know that whenever you have filling of the orbitals taking place, you have to make sure that each orbital gets singly filled first and then only pairing will start. This is also known as the Hund's rule of maximum multiplicity. And then you of course have your Pauli's exclusion principle, which states that no two electrons in an atom can have all the four quantum numbers the same. Okay. Next. Now, I mean, with this, we have completed majority of the atomic models which have been proposed till 1926. And what we have was, we have discussed the Planck's model, Planck's theory, followed by photoelectric effect. After photoelectric effect, what did we do? Rutherford gave his model in 1911. Then in 1913, Bohr gave his model. Then in 1923, de Broglie gave his principle, that is lambda is equal to h upon mv. And then after that, finally, we arrived at the Schrodinger model, which is the electron cloud model, because it talks about the probability of the electron, right? And that is what is known as the quantum model. Next, please. Now here we've checked up the different theories of the atom, right? I have just summarized them for you from starting from Dalton and then the theory coming in. We missed on the J.J. Thomson's model, which came in J.J. Thomson's model, which came up in 1907. And then you have 11 for Rutherford, 13 for Bohr, 23 de Broglie gave his principle, using which we finally arrived at the wave character of the electron, and Schrodinger, based on the wave theory, gave his postulate of the equation, and finally we solved it, right? And then we can just take up some questions here at this point. And before we take up questions, I think there are some more definitions that you all need to note, which are those of what you have already done. The very first one can be of isotopes and isotones. You've done that? Just note it down quickly again, because this is all a part of your atomic structure. What we have is, we can just note down what are isotones. Isotopes is something that you have done before. Just note down isotones. Isotones are nothing but atoms which have same number of neutrons but different number of protons. Atoms which have same number of protons, sorry, same number of neutrons. Okay, but different number of protons. Isotopes are the ones with same atomic number but different mass number. They are the ones with same atomic number but different mass numbers. And then what is very important is all this is something that you've done before, but isoelectronic species are also very important. These are the species which comprise of same number of electrons. And here you can talk about different systems. Like for isoelectronic species, give me the isoelectronic species with O2 minus. Give me the isoelectronic species which match up with O2 minus. Cl minus won't have the same number of electrons. F minus. You will have Ne, very good. Then you will have Na plus, Mg2 plus, and so on. So isoelectronic species, remember, here we had same number of neutrons, isotones. So same number of neutrons. Isotopes with same atomic number. All right, or same number of electrons. Then you have, isoelectronic species wherein you have same number of electrons in your different species. And this question is generally a favorite question of the examinations, that give the isoelectronic species or which of the following species are isoelectronic, right? Then something which is known as isodiphers. These are the atoms having same isotopic numbers that is same value of n minus same value of n minus p but different atomic as well as mass numbers. These are the atoms having same isotopic numbers, that is same value of n minus p, all right, but different values of, let me just take an example. For example, you can just note down 19K39 and you have 9F19. These are known as isodiphers. A unique or a rare question may be asked from this particular field. And you can remember the most favorite example of the examiners is potassium and fluorine only. You have 19K39 and 9F19. Okay. Then now to take down some question. Find out the ratio of nucleons. Find out the ratio of nucleons or in 16O and 18O. I'm telling you the mass numbers. You know what are nucleons? They are the neutrons plus protons. Find out the ratio of the nucleons. I'm asking you to find out the ratio of the nucleons. And what are nucleons? They are the number of protons plus number of neutrons. And in short, they are nothing but the mass number which is written on the top. Because number of protons is equal to the number of electrons. And what is the number of neutrons? It is only by definition that your nucleons are nothing but a combination of protons and neutrons. But your protons are equal to the number of electrons. Number of electrons plus number of neutrons give you the mass number. So that means your nucleons is nothing but your mass number only. But mass number is what? It is again nothing but the total of the neutrons and the protons only. So I'm asking you to give me the ratio for 16O and 18O. Very simple question. What is that? Simple 16 by 18. And what is that? 8 by 9. Next, calculate the number of neutrons in, be very careful, 17. I'm asking you the number of neutrons in 17 Cl35 minus. Calculate the number of neutrons in 17. The answer is, I give you options 17, 18, 35, 19. 17, 18, 35 and 19. Say A, B, C, D. What are neutrons equal to? It is simply mass number minus the atomic number. So here in this case it is very clearly. Sometimes it is given just to confuse you. Alright, let's do some more numericals quickly. You have a number of formulae with you now. Just add on to your list of formulae that your orbital angular momentum, please note down that your orbital angular momentum can be defined as, it can be given as under root of L into L plus 1 into H upon 2 pi. And similarly, your spin angular momentum can be given as under root of S into S plus 1 into H upon 2 pi. I just missed giving you those while revising the entire chapter. So here you have orbital angular momentum to be equal to under root of L into L plus 1 into H upon 2 pi. So, okay, calculate the orbital angular momentum. Question, calculate the orbital angular momentum of an electron in 2s orbital. Quickly do it. I repeat it again. Calculate the orbital angular momentum of an electron in 2s orbital. Very good. It will be simply, you want the options 4, 1, 0, h upon 2 pi. It is 4, 1, h upon 2 pi and last one is 0. So you have A, B, C, D. So all those of you who are planning to do some inky pinky panky should actually apply some mind. It's very simple. Orbital angular momentum is under root of L into L plus 1 into H upon 2 pi. That will be 0. So it will be 0. Okay, another question. The ratios of energies of photons. Calculate the ratios of energies of photons of 2000 angstrom, 2000 angstrom and or to that of 4000 angstrom, and that is, you have the options 2, 4, third option is 1 by 2 and fourth option is 1 by 4. You are supposed to calculate the ratio of energies of photon. A very simple question. What is your energy? Hc by lambda. What are you given? You are given ratios of the energies of photons. So lambda 2 by lambda 1. Because 2000 angstrom and 4000 is given. So it will be E1 by E2 is equal to lambda 2 by lambda 1. I repeat please for the solution here. What is our energy? Energy we know is equal to Hc upon lambda. So energy is inversely proportional to your lambda. So if we are calculating the ratios of E1 and E2, that will be simply equal to lambda 2 by lambda 1. And what is that? 4000 by 2000. So the answer is 2. Okay. Then another problem, take it up quickly. The emission spectrum of He plus. The emission spectrum of He plus ion is the consequence of transition of electron. We are talking about the emission spectrum of He plus ion is a consequence of transition of electron from orbit N2 to N1. From orbit N1. And please do not sit on stories which are written in the numericals. Just move ahead with the data which is given in the question. Okay. Now given that you are given 2N2 plus 3N1 is equal to 18, and you given another equation 2N2 minus 3N1 is equal to 6. Then what is the total number? You are supposed to tell what will be the total number of photons emitted. What will be the total number of photons emitted when electron transits to orbit N1? Just go through the question again. It's a simple question. Emission spectrum of He plus is given, and they're saying that the transition is occurring from N2 to N1. Given that you are given two equations, 2N2 plus 3N1 is equal to 18, and the other expression is 2N2 minus 3N1 is equal to 6. You know how to solve linear equations? So just solve and get the value of N1 and N2 simply. 6 and 2. So I have got the values of 6 and 2, and then you are supposed to then what will be the total number of photons emitted? That will be equal to 8. There's some error in the question given, but then if you've calculated N1 is equal to 2 and N2 is equal to 6, that is absolutely correct. Okay, the values of N1 and N2 are given, but none of the options is correct, but the answer I think is absolutely correct. N1 is equal to 2 and N2 is equal to 6. Okay, then you will have some conceptual questions also of this type. Just carefully listen and think about the answer. Which of the following postulates does not belong to the Bohr's model? So for that, you should have a quick go through the Bohr's models, theory, and the postulates. All the postulates, and we'll devote the last 5 minutes to the quick recapitulation of the entire atomic structure model. Okay, I am repeating the question. Which of the following postulates does not belong to Bohr's model? A. Angular momentum is an integral multiple of h upon 2 pi. Correct? Right? The electron stationed in the orbit is stable. Bohr, he stated yes, it is stable. Third, the path of an electron is circular. Yes, circular. We have been talking of circular motion only. Naturally, what are you left with? The fourth one, that is the change in the energy levels of electron is continuous. So let me tell you the change in the electron levels is not continuous. If it is continuous, what will it become? Classical. And if for quantum, you need to have discrete energy levels. Okay. Then you have a direct application question that you can solve. All right, take this question. During the emission spectrum, during the emission spectrum, the first line of Lyman series of hydrogen atom occurs as lambda is equal to x angstrom. All right, lambda is equal to x angstrom. The wavelength of the first, the wavelength of the first line of Lyman series of He plus will occur at 4 by x. Second option is 3x. Third option is 3 by x. And the fourth option are 4x. I repeat the question. During the emission spectrum, the first line of the Lyman series of hydrogen atom occurs as lambda is equal to x angstrom. The wavelength of the first line of Lyman series of He plus will occur at which of the following? Now just think, here you have to take your N2 and N1. The formula that you will be applying here will be 1 upon lambda is equal to RH into your 1 upon N1 square minus 1 upon N2 square. You know your RH, right? And 1 upon lambda you can get that is equal to your 1 upon x. So you have N1 can be taken as 1 and N2 can be taken as infinity, right? Take N2 as infinity and then solve the question. I am telling you the methodology. The working formula for this question will be 1 upon lambda is equal to RH into 1 upon N1 square minus 1 upon N2 square, where N2 will be taken as infinity, N1 will be taken as 1. So you get your RH to be equal to 1 upon x. And then finally you have to talk about the wavelength only. That will be equal to, here that will be equal to 1 is equal to 1 upon x into 4 into 3 upon 4, because we want the wavelength from here. Once we calculate your RH, which is equal to, RH will be equal to 1 upon x. Now using that RH, we are supposed to calculate our wavelength. That will turn out to be equal to 1 upon x into 4 into 3 by 4, because we are supposed to tell the wavelength of the first line of the Lyman series of He plus. Right? And you have RH into Z square into 1 by N1 square minus 1 by N2 square. So that will be 1 upon x into 4 into 3 by 4. So ultimately will turn out to be equal to 3 by x. Okay, next question, which is again important. Number of nodal planes. You have to talk about the number of nodal planes of 0 electron density in the dyz orbital. 1, 2, 0 or 4. We have to talk about an important concept of node. We have to talk about an important concept of node. Please remind me for that. Nodal planes, we are talking about dyz. dyz is a double dumbbell shaped which is along the y and the z. So here in this case, one of the nodal planes will be xz and the other will be xy. Please remember that here I will just talk about the nodal planes quickly. One of the nodal planes will be xy and the other will be xz. So for any of the d orbitals that we talk about, we have, see, we talked about s orbital, we talked about p, we talked about d. Let us just concentrate on these three first. S orbital has only S, so it can get filled by 2 electrons according to Pauli's exclusion principle also. P is triply degenerate. What do you understand by degeneracy? Please write down the meaning of degeneracy. Degeneracy refers to existence of more than one energy levels, existence of more than one energy states at the same energy level. Please, this is a very important concept that we just missed on. Degeneracy is nothing but it is the existence of more than one energy states at the same energy level. Say if the energy for two things are coming out to be the same, then they are degenerate. Now here for p orbital, we have px, py and pz. And if I draw the pictorial representation for px, you know, we have three dimensions, x, y and z, which are mutually perpendicular to one another, right? Z may be coming out of the plane of the board. So here, if px is the one, then px is situated along the x-axis, right? So here the rest, here wherever there it is meeting the axis, that point is called a node. What is a node? It is the point where the probability of finding the electron is negligible or zero. Why am I saying negligible is you will understand that in higher studies. So node is the point or the region of space where the probability of finding the electron is zero. In majority of your books, you will find it only zero. So let it be. Okay. So when I am talking about the nodal planes in totality, so here if you look at the YZ plane, can you look at the YZ plane? The YZ plane would be just cutting through. That is a nodal plane. You getting the point? It is along the x-axis. So naturally XZ has the orbital and your YX also has the orbital. YX is the plane of the board because your X is here, Y is here on the plane of the board mutually perpendicular, and where is your Z? It is coming out of the plane of the board and going behind it. So PX is along the X direction. So what are the nodal? Where is the node? It is right there at the origin. What are the nodal planes? Can you see the YZ plane? It is a nodal plane. All right. So now when I am talking about, so for PX, it is along the X. For PY, it will be not along X, but it will be rather along Y. So what will be the nodal plane now? XZ, where your orbital is not contained. What do you mean by a node or a nodal plane? Where the probability of finding the electron is zero. And wherever you are drawing your orbital, there you have a probability. So if I am talking about, say, a PX and the nodal plane associated with it, then what is the nodal plane associated with PX? It is the YZ plane. If I talk about PY, now it is the XZ plane. And if I talk about PZ, then it is the XY plane. Clear? So now similarly, for the d orbital, it is 5 times degenerate. The degeneracy is equal to 5. So here we have dxy, dyz, dzx. Then you have dx square minus y square, and you have dz square. Right? These are the 5 orbitals which are possible. Now for the dxy, if I show you the diagram for, say, one of them, say if I have dx and y, then the xy is nothing but it is along x and it is along y direction, right? And similarly for, say, dzx and yz, it will be along y and z, and this will be along z and x. For dx square minus y square, is this diagram clear? If it is dxy, one complete dumbbell will be along the x, the double dumbbell will be along y. For dyz, one complete dumbbell will be along y, the other will be along z. For z and x, one along z and the other along x. Now if I concentrate on dx square minus y square, for dx square minus y square, what will it be? It will be in between, say this is x and this is y. So x square minus y square will be here and here. So it will be in the 4 quadrants that you have. It will be not along the axis but along the 4 quadrants. Clear? And if I talk about the dz square, please draw these diagrams quickly. All right. If I talk about dz square, it is something like this. All right. This is dz square. So you have a positive on the top. Forget about the signs. You have a ring around here, the origin point, and you have dz square. Right. So before I wind up, a quick revision of what we have done. We have completed almost the entire atomic structure. You practice as many questions as you can from the topic. Revise the formulae just instantly as soon as I leave you for the class. The very first thing, we started from the very basic. Leucippus Democritus, immaterial, they worked with mortar and pestle. Then after that, in 1808, Dalton gave his atomic theory, which was just talking about the indivisibility and atom to be an indivisible substance entity which cannot be divided further. But then later, Planck hypothesized his Planck's theory and stated that everything exists in discrete bundles, right? And that concept was not accepted, but it was first confirmed by Einstein in 1905 when he did his photoelectric effect. And in his photoelectric effect, he did give 3 or 4 postulates which are to be remembered. Working formula is equal to h nu is equal to h nu naught plus half mv square. Then after Einstein's theory, we had the J.J. Thomson's model again, which you've done in the previous classes. Then 1911, Rutherford did his gold scattering experiment, and then he summarized it up by giving the various postulate, but he could not explain the stability. Ultimately, electron was actually, the question was, why is it not coming to the nucleus? For that, you have the reason of electrostatic force and the centrifugal force. Then in 1913, Bohr gave his postulates. You have to remember the postulates, you have to remember the limitations and the results, very importantly. Energy, frequency, wavelength, velocity and radius. All right, and the time lag. Then once that is done, after the Bohr's model, de Broglie gave us dual nature. Using that dual nature, we talked about the electronic wave nature. Schrodinger gave his equation based on it. That is the quantum model of the atom. And what is Schrodinger wave equation? H operator psi is equal to E psi. H operator is the Hamiltonian operator, which is a total. From there, you get 3 quantum numbers, N, L, M. S is obtained from Stern and Gerlach experiment. From using the 4 quantum numbers, you also get information about the orbitals, suborbitals, subshells, S, P, D, and F, right? And once we do S, P, D, and F, we are able to write down the electronic configurations. Electronic configurations are written according to 4 rules. We have Hund's rule of maximum multiplicity. We have Aufbau's principle, Pauli's exclusion principle, and we've Aufbau's rule we've talked about. One more rule if I'm forgetting. So we can summarize all these rules to write down the electronic configuration and attain at the stability. And then you have to understand the significance of a node. It is the point where the probability of finding the electron is 0. And I'm sure after this class you will create a node here because you will move to your places and it will be absolutely blank. So the probability of finding the electron would be 0 or negligible. Thank you.